All right. So, give people a couple minutes to show up here. But what are we doing? We are fixing my. I got halfway through what I was doing yesterday, and my system crashed. So that was wonderful. So what are we doing? We're gonna finish with this kind of topic that I was working on, which was the idea of getting into the field. Like, how do we get in here? What do we do? Hey, John Dot, how's it going? How Linux developer? How are you doing? Yeah, so we'll blow through the stuff that we did yesterday, and people that want to go look at that can go watch that from yesterday. And then we're gonna hammer a little bit. Nico man, how's it going? Hopefully this stuff's useful to you. We're gonna work on hopefully getting you guys the skills. Now, one of the things I'm going to show today, let me give a little bit of disclaimer here. One of the things I'm going to show is going to be, it's going to look very, very advanced. Well, it was a senior high performance compute position type of questions that I was giving for an interview. So I'm going to show you guys that, but then I'm also going to let you know that we have more introduction type stuff out there. So, Links Dev, you're doing the short-term client work. $200 for setting up an LC. You can do Linux developer, depending on where you are in the US, you can definitely just start DBA, which is doing business as. I mean, I'm not a lawyer and I can't tell you that kind of stuff, but I can tell you all the states I know of, you can do doing business as you're setting that stuff up. The guy that I know that's doing some side work like that you're kind of describing is, okay, you've been doing DBA, good. Colchis has been doing some work with scripting that I understand. I don't know how that's all been going for him, but I know he was working through a lot of that. All right, guys, so let's get into this. We'll blow through the self-assessment matrix because we did it yesterday. If you want to go more in depth, this is what the self-assessment matrix looks like. The goal is to determine your skills and skill gaps. You go and you find the technical assessment skills that you think you have, right? This is your own assessment. Then you figure out what your interests are, and you look for the gaps between your skills and your interests, and that's where you decide what you want to be, right? What do you want to do? Then maybe you have some business skills that you want to hone in on and get better at, and then there's also your interests. So if you don't want to be a business person, if you have like a 1 or a 2 for your public speaking, but you also don't want to be a public speaker, maybe you don't care, maybe you don't work on that too much, right? And then we talked about a SWOT analysis, which is your strengths, weaknesses, opportunities, and threats, and then how to kind of put one of those together. Businesses use these a lot, but SWOTs are also for you as an individual. Now, we did this yesterday, so I'm not going to go real deep into this from yesterday. But then we had this talk for a little bit. Let me grab this talk here. And this was excelling in the engineering field after college, but I've wiped this and said for everybody. And we were getting into, again, when my system crashed yesterday, we had gotten down to, what is the purpose of an engineer? What value do we add to a company? And hey, Ekshanya over on the YouTube side, how's it going? If you understand the value you add to a company, then you can start to think about how to keep yourself valuable, right? If the business thing that you do as a Roman soldier is to keep your gladius sharp, or to stab people with your gladius, that's what Roman soldiers did, then keeping your gladius sharp and ready to come out of its sheath is probably the most important thing for you. Well, we don't really do that as much anymore, so we're more on the engineering side of things. If the value we add to a company is fixing problems and building new things, we need to understand how to keep ourselves ready to do that for businesses, if that's what we want to do, right? Again, that's why the self-assessment came first, is what do I want to do? All right. We talked about this. We talked about learning how you learn, and we got into that, and we were down in certification when my system crashed. So we're going to jump through these real quick, and then we're going to get down to certification, and we're going to look at some system stuff, okay? So anyways, learning how you learn. Everyone learns a little different, but, figure out a schedule that works for you. Make time. Do it daily. Don't cram once a week. Find what you're interested in. We've got a self-assessment. We've got a lot of things down in Discord. I would almost say you're going to be overwhelmed with things that you're maybe interested in, but dig in on something that you want to do, right? Something you want to do as a career. And then work on projects that allow you to do what you're interested in. We have a lot of that in the Discord, a lot of things available for you guys to get involved with if you want to. So we talked about how you learn. This is kind of the academic side of things, and then how you learn. This is kind of the the hands-on, practical way that people learn things by doing them. We got down here into certifications, and we were talking about some of the certifications, and I gave you guys some links in our Discord. Right, this is one of my favorite things about our Discord, is if you come up here. Maybe one of the main things that I think is important about our Discord is you come right here and you go to like beginner start here. Where's it at? And it shows you all of these certs that are free right here that you can go start getting yourself a little bit of skills in. We talked a little bit yesterday around if you're going to have a resume, lead with what your strengths are, right? This is my actual resume just carved down so it doesn't have all my info on it. But it's a one-page lead with what I'm strong or what I think people would want if they were going to be choosing me out of a pile of people, because that's really what's going to happen. You're going to be going up against other people that this company also thinks could maybe do the job. And then your goal is to show them that you can do the job better than, maybe other people, right? So, get back in here. All right, so we had some certs. There's some really good free training with cloud certs with AWS and Azure. AWS, you'd start out as a certified cloud practitioner, and Azure starts you out with the AZ900. I hold both of those. I can tell you all about them. I think the differences between these are greatly outmatched by the similarities. When I got my AWS cert, I probably studied for about 16 hours. I kind of kept track. And then when I studied for my Azure cert, I only studied for about 4 hours because everything was so similar to this. I just blew right over the top. I was also working in that space, so it was a little easier. But I'm saying these certs are out there for you to study. I think it takes about 16 hours for each of them if you were going to do them independent of each other. If you want study guides or more stuff about that, we do have that down in the Discord. So we got a little certification channel. You can ask about it. We'll link you over to where my resources are and that kind of stuff. I used to do that like so long ago on stream on Twitch that I wasn't even streaming on YouTube back then. So I can't even link you to YouTube. Maybe I'll have to re-record these for YouTube as well, as far as the AWS and Azure stuff that I've recorded. So, all right. Here's all the free ones that I know about. The cert is free and the training are free. So general engineering stuff, Six Sigma processing, like if you want to be not just some Linux engineer, we all do Linux, but maybe you want to be a different type of engineer that just does Linux. Six Sigma, Lean Six Sigma, there's nothing wrong with learning those. Nilin Dude said you did the AWS cert, you learned a bit, you felt it was just an advertisement. Yeah, it really is. Their CCP cert really is this right here. It's just them giving you the glossary of all their stuff. It really is. Some of the like Solutions Architect, Associate, and Pro gets a little more into how you deploy stuff in their systems. But yeah, pretty straight, yeah, I would say it's basically like an advertisement. Well, they want you to use their stuff, right? So that's fair. But anyway, so Six Sigma and Lean Six Sigma are huge. You can go as deep into that as you wanted to if you really wanted to get into process engineering and that kind of stuff. Yeah, the Microsoft Learn is free. Yeah, this right here. The training for Azure, all this stuff is free. Yeah, easy money, that's true. So you can get into there and learn those topics, sure. So down here, this is the ones that I know of where the training and the cert is free. And some of the guys were just talking again about going and getting the Gremlin Chaos Engineering. So we probably have about, if I had to guess, probably like 80 people on our server, in our Discord, that have this Chaos Engineering cert. Some of the guys went and did it in like 4 hours. Some people, I recommend going spending a little time with it because there's so much good information there. But Chaos Engineering is fun because it is the bedrock of what we consider like site reliability engineering, right? How do we do this stuff? And Xshunya, you're exactly right. It's how you chat with other engineers. It's the language of the engineers in that space, which, guys, it goes so far along when you're talking with other engineers to be able to talk about terms and things in like or any ideas in like terms. It is tremendously valuable. It immediately sets people to like, well, okay, this guy at least has a framework for which we can discuss the things I want to talk about. And honestly, that is one of those things that sets people pretty at ease in interviews if you understand the terminology. There's a Gremlin cert, and then this is just a really good, I'm going to link the GitHub to people that want it. This is just a really good little GitHub on the topics of chaos engineering. So I'll link this to people that want it. Boom. This is just some person. I do not know them. But they have really good links on the culture and like the books, right? You go click on the books, and here's a bunch of books that you can read. And most of them are free. All the Google stuff here, this is all free. The SRE books from Google that I'm always showing you guys and referencing, those are free books you can go read and work on. So chaos engineering, right? Learn about it, learn about the tools, and go maybe contribute to some of those and see what people are doing. So much interesting stuff there. And it's just another thing. If you have nothing, guys, I keep telling you, if you got nothing on your resume, I got literally nothing over here to show people, I can at least put at the top my little Gremlin cert. Guys, I have my Gremlin cert on here. I think it's hilarious. And then fun fact, ever since I got that back in like I think I got that in 2020. I have been asked, every interview I've ever done since then, I've been asked, hey, what's that Gremlin Chaos cert? What is that? People are just curious about it. And then I get to talk about my understanding of site reliability engineering and what it means to do a like a walkthrough and a sandbox test, and how chaos engineering ties in with the scientific method. And I can show that I can walk through logically how we would do tests, and that I understand the difference between prod and dev and these kind of things, and all these things that people want to know that you understand before they ever turn you over in charge of a system, right? Before they hire you as an engineer or an admin, because you're going to be touching their live system. These are all the things that might be interesting to somebody, right? So I show you guys these things because I think that they're very valuable. This API lifecycle one, I want to emphasize, this is the wrong address here. But if you go on our Discord, this is the correct address. We have the right address. API Academy Learn Upon, they changed it. So I'll link this for you guys that want it. Here it is. So here's the API Academy, moved over here. And then this is free training. And one of our guys went through this a few months ago. So this was still free training a few months ago. So this should still be free. We have good, there's a good study guide that one of our guys put together right here too. Sorry, I got like the hiccups a little bit. So we're back here, we're studying, we're getting ready, we're thinking about, we already did the self-assessment, so we know kind of what we want to do. Then we're looking at, how are we going to take it in chunks and learn about it, and how are we going to bolster our resume a little bit to help us understand engineering in general around those different topics, right? This is what we do, right? And these are just ones that I know of. If you want to go study any other thing, that's on you, right? Like find the things that are interesting to you. Maybe you want to be a SAP engineer. I don't know anything about that SAP stuff. That SAP, maybe that's the thing. Maybe go find a group. One of my good friends, he does a thing called Measure Slack. Measure Slack has like I think they have like 50,000 members now. But anyways, they are a Slack channel that does data analytics and like Google Analytics and Adobe, like all these different analytics platforms. That's what they do over there. And that's what they talk about. And that's, find that if that's something you want to get into. My buddy Jared got into that when he was first starting out, and he was entry-level data for a big company, and then 3 or 4 years, I think it was about 5 years later now, he's like a data architect for a company. And just because he kept working through stuff and getting better and finding, right, and he tells the guys in the Discord how to do it, and all you got to do is start working at it, right? That's the first thing, is you got to take that first step of whatever you're going to do. All right, so anyways, here's the training that we were talking about, where the certification is not free, but you can still get training. I think Killer Coda is maybe the best place to spend time on the web. If you spent 15 minutes every day and they're doing Linux commands, you would probably at the end of the month have done thousands of Linux commands, and you would at least, I think, know about moving around in Linux more than anything else. I have a bunch of labs in there. Everybody, there's thousands of labs up there that aren't mine. You can learn other Six Sigma belt stuff. That's all free training. All the training's free. We talked about Terraform and Vault from HashiCorp. They've got free training out there. There's data science stuff on Kaggle. You can go get involved with LeetCode and all those. There's all kinds of things to go work through if you guys want to get into some of these different things. I still reference to this day W3 schools. I've been referencing them for more than 20 years for just basic web stuff. If I ever need to do something, just basic web stuff. General Linux, you know Linux well, but you want to understand Bash or this is the Linux documentation project, and you want to understand better how to do looping, or maybe you're not very good at file test operators. That's one that I always tell people. I know the file test operators that I use, but I don't memorize all of them. That sounds like just insanity to me. To just know all of them just to know them. You know, am I going to be on a game show one day? No, I'm a systems engineer, right? I need to know the thing I need to know, so I'm going to reference it if I don't know it. And that's what I use that for. And then web security, there's some really good training. They have a tremendous amount of training on portswigger.net for the tool is Burp Suite. Burp Suite is a way to automate testing against your web servers and web services, right? Atticus Now, how's it going? Xshunya, Maggie is sweet, and they give you a multi-GPU setup to practice well. I've never played with Maggie, but if you got a link, Xshunya, if you don't mind dropping in the Discord. Oh, is that on? Oh, Kaggle? Yeah. Yeah, I think Kaggle's great. Kaggle will teach you how to use Jupyter notebooks if you don't know. And I think maybe they even have some RStudio in there. I'm not sure. They got a lot of good stuff in there. All right, so now another thing is I think that it's valuable to build yourself a home lab, spend some time building out equipment or software that emulates the industry you work in. So for me, I've got my Linux environment. I can go do pretty much anything I want in my home lab, right? I can jump between my systems. I can go hop in and do whatever work I want to do. I have it set up where I can jump into a jump box and then keyed out to any of my different environments that I want to. I have lab environments where I can do security things. I have lab environments where I can do normal admin type things. I have the ability to quickly reset my lab back to where I want it, right? These are all things that I think are important. My lab is highly virtualized, right? Like we use XCP-ng around here, which is not necessarily the only way I would tell you to do it. There's other tools that are out there, but I like XCP-ng. Let's see if I can connect to everything. And this shows you my, is one of these down? I wonder if one of my servers is down. No, he's not. He was just turned off for a second. All right. So then I can go and I can look at my servers that are there. I can get console access to them, and I can start to understand the difference between this, right? I can SSH to Hammer maybe 25 here, right? And see it. But let's say he was down via SSH, but maybe I could ping him. So maybe, maybe I can ping Hammer, or even ping like Rocky, right? And I can ping him, boom, SSH to Rocky 17, and maybe he's not doing what I expect. So I come over here, and sometimes we have to go into the console on a box. And the console is what we consider like an out-of-band management to touch the server, not over SSH. So SSH assumes that the network's up and the configurations are right and everything came up good. But if it doesn't, maybe I have to jump in through the console directly. And one of the bad things about jumping in at the console, though, is I don't have the ability to copy and paste because I'm sitting at like a console. This is almost analogous to just having a keyboard and a mouse when we used to push our crash carts around back in the data centers, right? So this was the way that we would do that. We'd come over here and, maybe I should check my uptime and, who am I, and IP, maybe BR, ADDR, and see the IP addresses and make sure that it's up. But if I can connect in over here, I know I don't need to do that. However, this is just another way to get access to my systems, right? So in a home lab, I think you should build out some equipment or software that emulates the industry that you work in. Again, there's a lot of free stuff that you can do before you get to this point. But if you're going to be trying to really get in here, I think that you should build stuff. You can develop and work on any projects that we talk about later. So there's two things that I want you to either build for home or interest hobby stuff, or stuff directly related to what you do in the industry. You can work on things that interest you. It gives you a way to still mess around with technology, but still decompress from long hours of engineering. Like I can go just crawl around in my servers here and have fun and not really feel like I'm working, but I'm still doing stuff that goes towards my goals of, having an environment that people can log into and system stuff and all these different things that I'm doing. Now, the stuff that I have costs about, I've been building it up over many years now, but they're older Dell servers and probably a little over 500 now. But over the course of like 5 or 6 years that I've had these servers running, it's not that big of a deal. You can also do a lot of free engineering in AWS. and up to Azure as well. You can spend very little money or no money getting up to speed and doing Linux if you needed to, right? Getting into deploying stuff and all this kind of stuff that's there for you. I come over here a little bit, and maybe I pull this up, and I pull my other thing go here, and then I can go look at what's kind of going on in my environment. I can make sure that servers are up. I can see that I've got Kubernetes running. I actually need to, make sure that all my systems are up like I expect, and I can see everything here as though I were sitting at the console of the machine, which is very important. It's very important to understand the different ways that we get into servers if we want to get into the industry this way, right? So build yourself a home lab, and then what can you do? You can do personal projects. You can do stuff that's not directly related to what you do, but maybe it's something fun. Like, for example, I enjoy music. I've studied digital signals since college, and I can do all kinds of stuff with that down inside of my Linux servers if I want, right? I have some projects I haven't touched in a while, but they exist that do digital signaling, right? You can run, in my case, I run a bunch of labs out on Killer Coda where they show you how to do system stuff. This is things that I write for fun, right? Maybe you go in the Linux labs. There's 36 Linux labs now, and I drop you in and say, just go look around the Linux box. Maybe you've never been in a Linux server before, and this lab will start you off on your journey of doing basic Linux stuff, right? You're a new sysadmin at a company. You've been tasked with finding out information about a set of servers that has little or no documentation on it. That's very common, right? No documentation on a set of servers. It's almost the tale as old as time, right? So what release and version, what kernel, and if you don't know what any of these things are, now you're going to know, right? Because you're going to go do the lab. So we hit cat etc release, and we see information about the versions of servers that we're on. We see that they've recently updated these labs to all be Ubuntu 20.04. Then we can check the kernel version. We're on kernel 6.8. That's the latest kernel version I've ever been on, right there, right? Uptime. See how long this lab has existed before we got to it, because there's a pool of servers that sits there and we can connect to. And then maybe I can look at how the system was booted, what names were given to it, what options were given for how it's going to find its root according to the etcfs tab, right? And there I see that it was looking for this label here for Cloud IMG root FS, and then I can go dig in onto any of the stuff. Shadow Slayer said, what's the name of this particular presentation, and by what name should I find it on Discord? This one right here is Twitch excelling in the engineering field, so there's a couple of them. If you go down on our Discord, down to presentations, you would find these are ones from other people that have come and talked, and different things that we've done. But excelling in the engineering field should be right here. Here, this is the one that I'm looking at. And then the other one that I was doing, the Linux sysadmin, I've pulled that up a few times during this, I think yesterday. We've got the Socratic method for Linux. A lot of people really like that series. That's about a 6-hour-long series of just learning Linux through the Socratic method, asking ourselves questions about how we understand things. And then the self-assessment's right here. So the self-assessment's the one that's behind all of this, and that's the one that's kind of where you're walking through things. All right. So personal projects, like these are things that you build in your lab and you play with. We talk about all the time. You even see it probably going across the bottom of the screen. We're all hobbyists, guys. Like, there's nobody that hangs out with us that doesn't do Linux for fun, right? Like, and I know that's a double negative, but what I'm saying is we all enjoy doing this to some level, but the goal of our group with you guys, with anybody that wants to join, again, go join our Discord. We're almost at 4,000 members. You can ask the guys, have I ever charged you anything in the Discord? There's nothing to buy. Just go in there and start working with other engineers on getting to do this stuff professionally. That's the goal. We're all hobbyists. We all do this stuff for fun. Everybody here can talk about their one adventure or maybe many adventures in Arch, but we don't live there. We go and we do professional things from there. So that's where a lot of us kind of go. Shunya, I love doing the Socratic stuff. I love just sitting here talking with you guys about this stuff. So that's kind of good. And Zashinko, hopefully this stuff's useful to you. Yeah, and also thanks for the subscription with Prime earlier. I appreciate that. Hopefully this stuff's useful to you. But those are personal projects. Then there's also professional projects, things that you're interested in, but also directly relate to your job. So I do a lot with Ansible. Guys, I literally hit every day thousands of servers with Ansible. And that's not an exaggeration. I work on probably about 8 different government contracts right now for different reasons. And I do Ansible all the time, right? And it allows me to automate things, but I also play with it in the home lab. You guys have seen me just run it against a bunch of servers for fun, right? We can just hit Ansible and check the uptime of all of our servers and make sure that they're all healthy. And that's just little ad hoc stuff. Atticus, now, Kaggle is free if you have like a Google federated login. And I think you get so many hours of processing for free and some of that stuff. Yeah, there's a lot of training in there, Atticus. There's people who have built pretty good careers out of just playing around in Kaggle for the last few years. Yeah, there's a lot of stuff. And there's little competitions for people, you know, in our Discord. If people wanted to group up and go do Kaggle competitions, you absolutely could. I think that would be great. Most of you guys know I'm an amateur data scientist. I'm not a professional one. I'm a professional systems engineer. That's what I get paid for. But I like to play around with data. I like to make data do things for me. But I'm not a professional in that space. I do it for fun. Doesn't mean you can't know things, but it just means that I don't do that for money specifically. But yeah, Kaggle's great, man. I think Kaggle's one of the best things on the web too. Yeah, 20 hours GPU free weekly. Yeah, you can go set up your Jupyter notebooks right in there and just write stuff. Yeah, and then you can test it. You can do competitions. You can show it to other people and have them review it. Yeah. Yeah, Atticus, Killer Coda and Kaggle will get you a lot of hands-on for sure and get you guys pretty close to some of this. Now, I also, some of you guys know, I monitor everything. Like at work, I'm the guy who builds a lot of monitors out. I do a lot with security too. I build a lot of security STIG type things and STIG reporting. This is an older presentation because I'm well over 5,000 servers now. But this was back when I was just working at AAA, which we had about 5,000. It was about 1,500 Linux and 3,500 Windows, which I was the platform lead, so I did both. But I digress. I track everything, right? So in my home lab, I have Telegraph to InfluxDB to Grafana. I pull system data. I have weather data going in there. And if some of you have never seen that, it kind of looks like this, right? You can go in and you can look at all of the things that are going on inside of our little system. And then, if you guys haven't seen it before, we turn on Revolver tabs, and this thing will just start switching through the things automatically for us. It'll go from, here's all of our Prolog servers that I care about, that are non-lab servers. These are like my home lab. These are my home personal servers that are my production servers, not the lab servers that I let everybody use. This is my security and connectivity section, so I can see how many people have been banned, out of logging in and getting themselves kicked out forever. And then over here, we're going to see the logs of user activity against my devices. So these are in the last 6 hours. Oh, you know what? I don't even have that set back to, let's set this back to secure real quick. In the last 6 hours, these are all the people that have gotten themselves kicked out forever from my system right here, right? And then we have different things that are going on, but these are my dashboards that let me know how much root server usage I have, how much CPU and memory usage do I have, and why are they spiking high? Do I know that? Well, I happen to know that they're running antivirus every night, but maybe for different reasons. So, yeah, Zashinko, hopefully, yeah, this stuff's all useful. Networking Primer is one that I really have to update because I did it to try to keep it under about 2 hours, and I do need to update the Networking Primer to just have more information for you guys. And I will be updating the primer one of these days, and maybe just making it like a networking channel, like a networking playlist over on the YouTube side of things. So yeah, hopefully this stuff's useful to you. That's the goal, right? I try to, I just got done working all day, and then I just taught a college class before I came here. I don't want to waste your time. I don't want to waste my time. I have college stuff to do tonight. Oh shoot, I have papers to grade, and I have a discussion post for my college because some of you guys know I'm working on my PhD right now as well. So I have a post to do for that, and then I have multiple other things. So I'm busy, right? I'm busy. I would have Ranger Cam on, but we had a party this weekend, and I have not hooked Ranger Cam back up. But I will hook Ranger Cam back up, and then you guys can see that. But build out all of these pieces right here and practice them. I'm doing this stuff for work, but this stuff is all there. Also, if anybody's interested in doing these labs, I have a bunch of this out here in the Linux labs for Killer Coda. So if you're like, Scott, I want to go build, maybe I've heard about Prometheus and Node Exporter and I want to learn this stuff, and I say, well, here's a lab right here that will start you off on building that stuff out, right? So here's a lab, and then you can go in and you can say, your team has determined they need to monitor telemetry in your environment. And you know that Grafana can do that as a visualization tool, so you plan to deploy it on the server as a daemon. Boom, deploy Grafana. There's some stuff to read about if you need help. There's just all kinds of stuff here.
I think I clicked the wrong button.
Hey, Root Guy. Hopefully this stuff's useful to you. Thanks for the subscription with Prime. You know, you guys can use those anywhere, but if you choose to use them here, that always feels good. Keeps me motivated. But yeah, you guys can get in here and start touching these things and learning how these labs and different pieces work. And man, you could, once you start to build these pipelines, you can start to build them from anywhere and get all this type of data and start to monitor it. In my home lab, I also have, let me open up some VS Code here. I have some diagrams here where we can go look at, I think this is it right here. Yeah, this is my diagram in my home lab. This is what we do in the home lab. This is how I monitor all my stuff right here. So if you're ever like, hey Scott, what are the components or pieces that go into your lab? Here you go. How's it going, Control Byte? Yeah, Control Byte, I think you left yesterday. I think you mentioned it. And then like a little while later, my stream crashed. So this is part 2 of yesterday. We have done our Linux, or we've done a self-assessment for how much we like technology and what we think we're good at. We've done we're in the middle right now of looking at how to keep ourselves relevant as engineers. Yeah, you didn't miss much except me swearing, but nobody got to see that because my system crashed. Guys, and by the way, all the stuff I'm showing you is also up in our Discord. So if you're like, man, how does this, you know, how there's so much stuff, where do I go? Yeah, look, even over here. Oh, I thought it said my crash, but yeah, I had a big old crash yesterday. That was super annoying. But anyways, professional projects, understanding and building things that, again, are either personal to you or professional. But the point is, at the end of the day, we're here in Linux doing Linuxy things to be able to understand, you know, okay, I'm here, you know, I want to know this about these things. How long have they been there? What's the oldest one? Okay, these were being created as a system. Like, I can go and start to figure stuff out about my system with very simple commands, but not if I'm not, like, familiar with how it works. So it's almost like you want to, I was using that example of that song, Go Johnny Go, where it's like Johnny could play the guitar like he was ringing a bell. Now, I don't know if that resonates with some of you, but just know that ringing a bell in a band is super effing easy. You just go up with the bell and you go down with the bell. And you go up with the bell and you go down with the bell. And hopefully you can ring that bell on time with the band so you don't get kicked out. But my point is, if he could play his guitar that well, the point is he just understands it. And like PWD, CD, LS, these are like simple commands that you have to do as well as you walk around your home. Or as well as you get in your car and drive to the store. You have to be able to move in this space. Does that kind of make sense, right? And what I would tell you is just getting in here and immersing yourself in it is a good way to do it. And if you have to jump in slowly and you have to use some of these other tools, there's nothing wrong with that, right? And Chico, yeah, thanks for the happy belated birthday. My birthday was Saturday. We had a pretty big party over here. We had about probably 60 people over. I think we were a little under 60. We were probably about 50 people. But we had, it was a good time. We had a game truck come over for all the kids, and we had our drift trikes out front. People race around these little drift trikes that I have. If you've never seen the drift trikes, they're funny. They're like big wheels for adults, so they're pretty good. PWD, Public Works Department, fair enough. All right, so then we get down into like a book collection, right? I am a big fan of keeping a collection of books for reading and reference. I think that the internet's great for referencing thing. One of the best things that ever happened to the internet was a thing called Stack Overflow. If you guys have never heard of Stack Overflow, you're probably not in the IT industry, but if you're in the IT industry, you're like, oh shoot, I was using Stack Overflow right before I got over here, right? You were probably using Stack, you know, it's just this great site. And that's awesome. However, Stack Overflow is not going to give you a lot of the rigor and correctness of, like that publishing of a book would have. So inside of the idea of publishing books, I'm a big fan of going and getting stuff off a Humble Bundle, right? Sometimes we do like Humble Bundle things inside of our Discord and stuff. There's a Lean Pub book that I put together. This is the only thing that anybody could pay for if they wanted, but it's right here. And then there's all these free books online, man. Guys, there's so many free books out there. All the SRE books from Google. We were looking at those ones earlier. What is this? My risky click of the day, Control Byte? What is this? What is this? Oh my God. Here's our risky click of the day. This is me riding. That is one of the best memes that has ever been made of me right there. Still running his route. So that's the drift trike right there, in case any of you guys have missed it. And that is me. And that is funny. I'm gonna keep that. I'm gonna make that like a. Let's save that image somewhere. Let's just put that here and like downloads real quick for a little bit. Hopefully that'll be. That doesn't seem like that's. Yeah, maybe we'll be able to open that later. All right, I'm gonna keep that around because that's funny. But my point is like the books. Like go to Humble Bundle, right? Go look at what's going on Humble Bundle. Look at this. There's almost always something good going. Now, one of the things about Humble Bundle that I like is, yeah, sure, I consent, whatever. When you go look at the bundles and you go look at the books, because there's games everywhere. Coding for the Curious, machine learning stuff, cybersecurity and forensics, they've got a lot of good stuff. Could you go on Reddit and find all of these books in a PDF format? I bet you could. But as you maybe get a little further on in your career and don't mind flipping $20 to mostly charity. A lot of it goes to charity. I think this one's like, yeah, it's typically $25 to get all of them. You can get all of them, and then you can sometimes go and pick a charity as well. I don't know if they always let you pick the charity anymore, but you used to be able to. And then you can change the way that the charity works, and you can set custom amounts and do a little slider and say, I don't want to give Pearson all that much money, but I'll give everything to maybe to First Book. I want to give them the most, right? And there's some limit to what you can give, but maybe you're like, I want to donate everything to charity, right? I like that about this. Maybe you want to go Microsoft Azure, and what was Sentinel? Sentinel's a good one inside of there. You get to learn the Kusto, Kusto, fucking query language. It always reminds me of Krusty the Clown, right? But maybe that's something you want to go spend your career in, right? I mean, I don't know what you guys want to do, but here's another thing. So I'm a big fan of getting a collection of books. You can find books that are out there. But there's just more rigor around the publishing of a book. There are a lot of older books that are available for free online, that kind of stuff, and that's kind of understanding and good as far as technical stuff. Technical books go bad very quickly, or not bad, they grow stale kind of quickly. And some engineering books that you can get your hands on are always going to be good because they're simple systems engineering, right? So something to think about. I think a book collection is good to have as a reference locally. Even if your network's down, you can still reference things. Physical books, I think some of you guys know, I have every book from every college class I've ever taken, and I have every book from every college class I've ever taught. So I have literally hundreds of college books here. From every time my college ever gave me a book, either that I paid for a whole lot for early on, or later on when they were giving them to me for classes, I have every one of them. So I'm a big fan of keeping books. All right, industry discussion. This is maybe the best thing I can give any of you. We were talking about yesterday. Maybe the number one thing I could have given you yesterday in the first part of this was in your in this one, right? In this discussion, was maybe in finding that you don't want to do certain things. Remember I was telling you guys my college students would come to me and be like, I hate this. When do I get out of like doing Cisco command line? And I'm like, you are going for like your Bachelor's of Science in Network Communication Management. You're going to be a network engineer. This is literally the next 30 years of your life. And if you hate this, you probably should get out of this now. And that was a very expensive mistake. I've told college students that. I've told them, like, if you don't want to do this a single another day, you need to get out of this field. But if I showed you a whole bunch of Cisco right now, right? We're not going to do a bunch of Cisco. But if I showed you a bunch of Cisco and you were like choking behind your computer screen going, oh my God, who fucking does that? Well, wouldn't that be like the best free thing I could have given you? Like of all the things I could show you the thing that you for sure don't want to do? Like if I just spent a whole stream right here just doing Linux and you guys were like, literally, that's how you like live for 8 hours a day. And I was like, yeah, you'd probably be like, And what do you come up to watch Netflix every now and then? I'm like, yeah, I'm watching Netflix while I'm doing this stuff. But if you couldn't stomach this for another minute, you probably shouldn't try to do Linux, right? I mean, and that would be a really awesome free thing for me to give you. You'd be like, shit, man, that was the best free education anybody ever gave me. Was some dude online showed me what I didn't want to do, and he was right. I didn't want to do it. It was all terrible. Well, anyways, so what could you do if you did know you wanted to do something? Is in the industry discussion here, we can get immersed in technology and kind of keep our finger on the pulse, right? I think this is very important. There's technology podcasts and topics that might interest you. I always try to tell you guys, like, I'm not saying you can't be entertained by whoever you want, right? I like, guys, I like stuff that's really stupid on the internet. But that being said, don't get sucked in on things that act like they're trying to teach you something, but they're not, right? Like, there's a lot of that on the internet. Find a Slack, a Discord, or a Usenet group that's about the topic that you're interested in, right? There's a whole bunch of them on the CISSP. You can go look. This was just a Reddit link that I had for CISSP. North America Measure Camp, and then you can find Measure Slack from there. And Measure Slack is one of the best things if you want to get into data analytics and Google Analytics and web tracking and those kind of things. And again, that's what my buddy Jared does. If you go on our Discord and you ask Jared, typically he'll be, or if you tag him in anything, he'll also answer. But if you don't tag him in something, you can come. Oh, where's he at? Jobs and interview discussions is typically where he'll show up, Jared. And if you just ask him, hey, what would you recommend? He'll typically give you guys a pretty good answer, I think. But he did a lot of stuff in data analytics. He still does. I think that you should get involved in open source projects, right? Especially early on in your career when you're trying to get some chops on your GitHub. Maybe you're going to show your GitHub to people. I tell you right now, if you're willing to write code and debug, you could be working on a project tonight. You can just go. You can go join all the mailing lists you want, as long as you can filter through the noise. I would find one or two that you're interested in. Are you talking about Prime starting a Twitch controversy? No. No, I don't think so. Anyway, so high performance computing, maybe you want to get into high performance compute because that's what I try to show you guys a little bit of. In fact, we're going to do one of my interviews for my high performance compute engineers. But there's a bunch of ways to go get involved with that. There's an Ubuntu section. Ubuntu put together a nice little, they were getting into, well, Canonical was getting into the high performance compute space, right? And they were showing, this is their blog for the different HPC stuff that they're doing, right? And then you come over here, and then there's HPSFIO, which is the Linux Foundation, like the CNCF, right? Their high-performance software, Neutral Hub for open source high-performance software. So they wanted to do performance, portability, and productivity. And then they've got a big conference. Looks like that one's already passed, but they have these going. And what I would tell you, too, about these is some of the guys, like my company is all high-performance compute, right? Like that's what my company does for the government and different projects and stuff. But now let's go look at the projects that they have. Apptainer is the same CIQ company that does Werewolf and Rocky, right? And then here's some other ones. SPAC, huge. SPAC is a really big one. And some of the guys that I work with are the active maintainers on SPAC, right? So SPAC is a package manager for supercomputers. We can just load up modules and do all kinds of installs very easily where everything is standardized. It's kind of like an Anaconda. If you guys are familiar with like Anaconda or Conda, I think it's called Conda sometimes. Or another way to think of it is almost like a virtual environment, right? It's very similar to that. So with SPAC, we can present all of these packages and people can load environments with packages and stuff. So SPAC's a pretty cool little tool for that. And somebody I'm trying to get to come talk to you guys at the in our August meeting. We're going to do a big meeting in August. We typically have a few hundred people there. I'm going to try to get one of the active SPAC maintainers, Dr. Reichert, to come talk to you guys. And he's a really brilliant guy. He doesn't ever make me call him doctor. I just call him doctor when I introduce him to people. And like if I introduce him as a speaker, I'll always say, doctor, because he earned it. But if you met the guy, you probably wouldn't even know he was a doctor. Well, except he's really smart. But he's not the type of guy to like make people, like make people aware of it, if that kind of makes sense. He's really good at what he does. So like in that sense, you'd probably. Like, anyways, my point is get involved in the industry. Find things that are interesting to you. I mean, maybe you're like a really, niche. You like some type of really like interesting Japanese art or something. Go find a group for that, right? But when you want to get into Linux, find a group that does Linux. If you want to do Linux as like a corollary, but security is your main focus, Go find something that's dealing with security, right? But again, I always recommend, don't get sucked in by infotainment. There's all kinds of groups out there that are, and all kinds of streamers even, that they're not actually teaching anything. There's very little coding going on. They're just showing you their chat scrolling by, and they're just talking the whole time. And guys, there's nothing wrong with watching podcasts and that kind of stuff. I'm just saying that's not really going to get you anywhere. You're going to watch that for years and never go anywhere. And how do I know that? Well, most of the people that are watching that stuff all the time aren't really doing anything, so it's kind of interesting. Xshunny said they have statically compiled version of OS Conda called Mamba. It's quite useful. Nice. Yeah, because then everything's the same. Everything being the same is one of the most important things inside of high performance compute. That's why SPAC is so big. If I'm going to run a workload across 10,000 machines, every one of those 10,000 machines needs to have the exact same version of all libraries and all code, and Python needs to be exactly the same, and any underlying libraries that I have to be exactly the same, and otherwise shit's not going to work. It's going to break, and it's going to come out, and it's going to be a waste of time. So those tools that standardize that for high performance compute are highly valuable. Very, very valuable. So, okay. Hundreds of free online labs, but again, you'll be working on your own with that stuff. But I posit if you find a group, Discord, again, guys, I tell you all the time, it doesn't have to be my Discord. It doesn't have to be the professional Linux user group. You can go find anybody that's doing the things that you're interested in, working through labs, doing the stuff that will get you into the jobs that you want to do, and then you're going. Zashinko, you're going to WGU for network security engineer? Nice. Yeah, we have, we probably have 10 guys on our server that have graduated from WGU. One of our guys that graduated in there, one of my former colleagues, and I consider him a pretty good friend, M-Pesa, he graduated from WGU in, I think he did his bachelor's there in like 4 months. He prepped for everything, and he just blasted through it. Now he's working on his master's in data science. Is it data science, data analytics? I have to ask him about it. But yeah, he's doing his master's right now. But he got his undergrad over at WGU, which is awesome, right? And with WGU, guys, if you don't know, you can go through it at your own pace, and then you take certs at the end, and you do all that kind of stuff. It's a very, very valuable way for people that are kind of on the go or doing systems work already to get into stuff. All right, let me show you guys stuff. If you didn't know, the U.S. government has all kinds of free resources for you guys. Zashinko, I could sit around and tell you all day about how great that dude is. Why is this not coming up? This should just reload. Is it not? I would have sworn. They got something wrong with their stuff. But let's just go to NOAA.gov with the library. Really, did they? I'm gonna have to. So I work for NOAA. If you guys don't know. Here we go. Let me go. Let me see if I can just link this. Here we go. I'll link this to you guys. This should work. Yeah, the upcoming seminar should work for you guys. Drop it over on the YouTube as well. And one of my favorite things about this is these are free. These are free to attend. And they'll tell you how to use the open data that NOAA publishes. NOAA publishes all kinds of data for you guys. There's so many of these things. Oh yeah, Zashinko, he also got a perfect score on his RHCSA and RHCE, and then he went and got his RHCA, which some of you guys might not know is when you get like 8 of your Red Hat certifications, they make you a Red Hat architect. So he's a Red Hat certified architect, RHCA. They don't really advertise that. You have to go look for that to find that. So he got that, and then he did all that. Anyway, so there's all these things that the government will teach you about data, right? We have data that we mess with down in our Discord. You know, if you come up to our, that's funny. If you come up to like our data analytics, I'll sometimes drop stuff in there that I'm working on. I drop some stuff for HIPAA. All the official breaches of HIPAA since 2009 that have ever happened are right here. So if you wanted all that data and you wanted to go chew through it and play with it and that kind of stuff, you could do it, right? And this is like, again, this is one of these things where maybe we want to go and find other people that are doing interesting things. This is one of the reasons Reddit's so popular. Why is Reddit popular even though it's like the biggest hive of villainy and scumbaggery on the internet, right up there with like 4chan and stuff? Well, the reason it's there is because people love, like, if you were studying for a CISSP and you were trying to find 10,000 other people that were also studying for their CISSP, yeah, some of them are going to be dirtbags, but they're all going to be people that are, doing something related to you. So this is why I tell you guys, it does not have to be our Discord. Find any Discord, find any group that's interesting to you, and go get plugged in. They'll help you be accountable. Go find yourself a little accountability buddy, right? find somebody that can like help you push along. I can't do it for everybody, but I can keep putting out material. We have groups running right now in our Discord, free groups, by the way, where people are studying for security engineering. We've got a Linux sysadmin course that we run not every 16 weeks, but for 16 weeks, and that's free. We got the security engineering course that we are just finishing now. I got to re-record the final piece of that. But there's stuff out there for you guys to do. And go find somebody that's doing this stuff, that's doing stuff that you're interested in, right? All right, I'll get off my horse on that. But industry discussion, very important. Maybe the most valuable thing if you're trying to learn how the engineers talk. Sit with the engineers, hear how they talk to each other. Hear how they talk about concepts and ideas and those kind of things and implementations that they've done, and then get involved, right? And one day, this is exactly how it happened for my friend Jared. Jared was in Measure Slack, and I think there were around maybe 12,000 people back then. And he used to ask a lot of questions as he was doing implementations at work and stuff. And he said one day somebody asked a question on there, and one of the guys who was one of the heavy hitters, had been around a long time, everybody was always asking him questions, was like, "Hey, that's a really good question." And then he tagged Jared and said, "Jared knows a lot about that. I've seen Jared answer that for other people. Why don't you ask Jared about it?" And he was like, that's kind of how he knew that he was getting this stuff, was the people that kind of were around in the Discord were starting to tag him on stuff. So I bring that up because then I say where was I going with that? If you're ever on Twitter or now X, right? If you see people are these are the lists of the top 20 data analytics people that you should follow if you use Google Tag Manager, Jared always gets tagged in that. So when people are making lists, people love making lists, right? Love sharing lists with everybody. It's been that way since the Tonight Show with David Letterman, right? He had his little, I think it was David Letterman. Yeah, he always had his top 10 lists. Well, people love making lists, and Jared's always on people's lists for that. And you might say, well, what's his background? He doesn't even have a college degree. He'll tell you. He's like, I did this all just by getting involved with the industry. And he's very good at what he does, but he got he kind of learned in the wild, if you will, by sitting with the engineers. All right, enough of that. Review. What did we talk about? Learning how you learned. You got to spend time doing this stuff, guys. There's no easy. I think everybody can do it, but there's no real easy way to do it. You just have to start. It's almost like you just have to get on there and start doing it. You can spend time around certifications. You don't have to spend money on certs. There's a lot of certs out there that you can study. The main point of a certification is it points you to a BOK, which is a body of knowledge. B-O-C-K. B-O-K. B-O-K. Just be okay. Oh my God. When I say be okay, the letter B. Okay. There we go. It's a BOK, a body of knowledge, right? Certifications. Build a home lab out. Do professional and personal projects, things that are interesting to you. Get in there and start working on those. Get a book collection, maybe. Maybe find one on the internet. I don't know. But I would tell you, as you're doing this longer, you'll probably just go find curated lists from people and buy them off a Humble Bundle and flip a nickel to some charity, and it's kind of nice and makes you feel good or whatever. And get involved with engineers. It's hard. It's not hard to just go sit with engineers. It's just engineers' time tends to be valuable. So if they're sitting and talking with other engineers, that's a good place to be sitting by and seeing what they're talking about and those kind of things. There are sometimes meetups, but meetups have mostly gone away since 2020. Everybody wants to work from home, so everybody just wants to get on. We used to meet, the Professional Linux Users Group's been meeting almost 12 years now. It'll be 11 years in August, actually. And we've been meeting, we just met at my house for a long time, but then we got online and started doing Discord right before COVID hit. And, that's kind of where a lot of the growth came, was everybody just wants to work from home, but The point is you can start getting involved. And then this is my last one, right? If you can't find an expert, but you're the one maintaining everything, maybe it's time for you to start to codify your stuff down, write your documentation, and start mentoring the next group and get the next group going, right? That may be what your thing is. And I will tell you, by mentoring others, you will get deeper into the system than you probably would have ever thought, because people are going to have questions that you never thought to ask. That's one of the main reasons I think I've told you guys why I'm a college professor, is because one, yeah, sure, they pay me a nickel every 2 weeks, sure. It's like nothing. Like if you knew my if you knew my college teaching rate, you'd probably be like, really? Really? I'll start with this. I won't tell you guys, like, because it's not polite, but it's less than a quarter of what I make per hour as an engineer. Now, I mean, I'm salaried as an engineer, but I'm saying my hourly rate is less than 1/4 as a college professor. So where I'm going with that is mentoring others is more of a activity of love, let's say. It is not necessarily something that but it can be selfish as well, in that I get to learn things and work on things that I might not otherwise have ever worked on again, right? So, okay. So questions, feel free to just message me on Discord, that kind of stuff. All right, so that was my talk about getting into the field. So what I was going to show you guys is, as we're kind of doing this is like it became a 2-part series because we crashed the other server. We're going to go look at like an HPC technical interview. This is coming from, me having given hundreds of interviews in my career. I'm always tasked to come in on technical interviews. It's funny, I'm asked sometimes to come in on technical interviews for things that I don't even do. But it's just because they're like, well, Scott, but we like you to sit down and see if you think this person's technical. And I'm like, all right, I'll do it, whatever. But this is one that I wrote up for a company I was working for a while back. Well, my company had the contract, and then I was embedded with this team. And this was a senior HPC technical interview that I put everything together for. So real quick, before we get into it, this is always my testing methodology right here. This is how we can standardize things as engineers and make them not... we don't want everything to be subjective. We want it to be objective. Subjective is if you're like, hey, Scott, do you like that cake? And I'm like, oh, yeah, that cake was okay. It kind of was pretty tasty and pretty good and stuff. And, yeah, I liked it. Sure. That's a subjective answer, right? An objective answer would be maybe if I took that cake and I said, what is the moistness of this cake, right? You can't use the word moist unless you're talking about a cake, right? And what is the moistness of the cake? And then I have like a measure of between like 0 and 10. 0 is dry and crumbly, and 10 is like there's stuff dripping out of it, right? And then I say, well, it was a 7. Objectively, it was about a 7. Now, you might say there's some subjectiveness in that, sure. But what I'm saying is objectively, I now have a score of 7. And then I take some other cake, and it's like a 3. And then when we rate those cakes and get to the end, I can now have an objective measure of how good one was versus the other. As opposed to saying, well, we did all this stuff, but I really just like that one the most. That's cool, but that doesn't help anybody else make decisions, because here's the thing. Somebody else that looks at that might go, well, I like drier cake more than that guy does. That guy's a jerk, but at least he left me with information that I can make my own decision on. Does that kind of make sense, right? This is objectivity versus subjectivity. If I just at the end of it tell you, well, I like that cake the most and that one and that one, I was probably eating too much cake. And 2, there's no objectivity. There's nothing you can come in and do with that, right? So anyway, so this is how we look at, any time I do a job interview. What's the purpose? Select the next engineer for some team. Scope, determine their capability to execute on the job duties. Out of scope, I didn't care about their personality. I didn't care if they picked their nose. I didn't care if they were sniffling or pushing up their glasses or whatever. I don't care, none of that stuff. That wasn't what I was there for. Non-technical capabilities, I didn't care if they could write well. I wanted to know if they understood systems, right? That was my goal for this. Normally, I would want to know if they write well, because that's a big part of being a good engineer, right? Methodology, apply an approach to objectively determine the best technical candidate, and then we'll use some template, right? Some scoring method. And then control all the questions to the same people at the same time frame and give them adequate time to answer. But keep it all the same. That's your control. Okay. So here's some specific responsibilities that maybe the HPC engineer might need to know. They might need to be able to maybe develop and document systems and service diagrams, procedures, and software build install notes. So typically, as an artifact of a build, there's two types of books that I build. I build the build book and I build the run book, right? And those are the two things as an engineer that I will publish with my versions of like if you were going to deploy a Linux server from one of my images or one of my golden, golden images or one of my actual container images, right? Those kind of things. Yeah, Root Guy said soft skills and communication very important as an engineer. I agree. I actually have a different talk. We'll see if we get to it today, but I think I have it open. It is called, it's this one. It's soft engineering skills. And down here we get into like presenting your data. And if we're talking about soft skills, like look at this. This right here is, I've seen this one right here actually be sent to a team before. Like I've seen one of my junior engineers, and then when this passed across my email, I was just face palming as hard as I could, like, really? Guys, I always use this top one right here as an example. I have been doing Linux for like 22 years professionally now, maybe 20, almost 23. I don't know what this says, and I look at a terminal all day. This is the same exact information as it came out of the terminal, though. And I can read this, and most of you can probably go, well, is the utilization over 60%? No. That is the proper information I needed. I needed to know if any of my servers were over whatever. Yeah, control byte, that's true. Use code blocks inside of, yeah. And by the way, guys, if you don't know what that is, it looks like this. Like this was dropped in as a code block, but we use it a lot in like Ansible. So like in the Ansible channel, yeah, like somebody had dropped this and it's like a nice little block, right? I tend to use 3 and then it just comes out as, where are mine? That's a nice little code block somebody just had. Yeah, code block, code block, code block, code block. I tend to just do 3 dashes and then it comes out as code, but it's not all pretty color. Mine tends to look like this. That's 3 dashes. See? All right. So anyways, the point is, some people grab pictures and that stuff. It depends on the Notes app that you're using. Is this one of mine? No, that's Chris's. But yeah, we got a lot of stuff up there. We got many, many years of people writing stuff in Ansible and stuff. But all right, but anyways, we're back here. Develop and document systems. Do you know how to do like a basic service diagram? Can you draw a simple thing? And I love Excalidraw, so I'm going to pull it up. Where's our Excalidraw? Right here. This is one that's gotten kind of cluttered over the years, but over the last year, ever since I did the first drawing. But this was my original home diagram. I tend to start somewhere on the left and the top left, and then, what happened here? Oh, we're still jumping through. Hold on, let me get out of here. And then we start on the left, and then we walked through how we get into my home lab and how all this stuff works. And in a pinch, this could be used to diagram out and show new engineers kind of how things are happening in our system. And we could start to talk to the different components, and you could start to kind of frame in your head how you get into the Bastion nodes, and then you jump in as a jailed user over to Streamer 1 or MC Hammer, and then you're a root user as you get into the boxes, right? Whatever. I can start to add information about it. But the idea is, if you're going to be an engineer and you're going to build things, you have to probably be able to hand those off to the people who are going to run those things. The engineer that can't hand things off ends up having to also be the administrator. And when you're the administrator, you're also working nights and weekends. Like I've been on call since last Wednesday. I'll be on call until this Wednesday for NOAA, right? And I have to take call. I mean, this is the thing that we do, right? But this is a part of our normal operations that everybody takes a part of on call, so we understand how everything works, right? But if I was building things, I would be building them and handing them off so that other people can maintain them. You are often, and this is a thing that one of my buddies, Salty Catfish, says often, you are not really building the code for the system. Yeah, sure you are. The system has to be able to implement the code and your syntax has to be right. But a lot of times when you're writing code, you're writing it for yourself in the future and for the next guy and for the maintainability of it. If you're just, doing stuff and then never being able to document it, you're really losing one of those main things that an engineer is supposed to be there for, which is making things, making things work, but also being able to support them and maintain them in the future. So now, create observability metrics and dashboards to assist in ongoing documentation efforts. Before you can even talk about observability metrics and dashboards, well, one, you need to know what a metric is, right? Metric is a measurement by which we look at anything. But what are important observability metrics, and how would I learn those? Well, I might go back to that SRE book, right? The Google SRE books are really, really good for this. So maybe we come over here and we go to like sre.google and we go look at these. These are really good books, SRE Google books, right? Boom. Just happened there. Okay. All right. Here's the Google books, right? And they start to talk about things like service level objectives, service level indicators, and then service level agreements between teams. And those kind of things start to be really, really valuable for observability because they're the metrics on which we determine what, and then they start to turn from service level indicators and service level objectives and then service level agreements. You start to develop what are called KPIs, key performance indicators. How do we know that this thing that's moving along, this set of servers, this fleet of servers even, is doing well? Like, are they all operating under 80% of their root disk capacity? Are they operating under 20% of their normal CPU load? And then do they spike up high during maybe our high load times? And then how do we deal with that, right? How do we do this? A lot of stuff in the cloud is natively doing this, but we should be doing this in our systems outside of the cloud as well, right? We need to be able to install, configure, customize, and maintain Linux software, including building software from source. So install, configure, customize, a lot of that stuff is now done by package managers. How do we get stuff in there? But building software from source is something you may have to be able to do. You may have to be able to download the source code, make sure you have all the dependencies, run your .configure, right, to make sure that you have everything, and then run your build against whatever your tool is, right? And some of this stuff is also easier. We were talking about that tool SPAC earlier inside of High Performance Compute Space. SPAC is a way that can help you to do this without having to do all the builds manually. That's actually one of the things SPAC does really well, is we could just have a cluster sitting there and then work through everything. All right, we need to collaborate with researchers, developers, and other engineers to develop creative solutions to solve complex challenges. Well, what this says is I got to be able to work with other teams. I often work with researchers and developers. I've often told you guys too, when I was with AAA as the platform lead, I had about 200 dev teams that were using my Linux platforms. I would deploy the Linux platforms, and those developers would run around and build all kinds of apps and stuff, right? That would then be in various levels of going to production. Researchers are doing, I work with researchers all the time at NOAA, right? But researchers are going to ask questions because they are not always aware of everything with Linux. They are good at the science and the data analytics part of things, whereas these guys are good at the software engineering side of things, but they don't have root in the environment. You have root. They didn't build the systems. You guys built the systems, right? Like as the systems admins and systems engineers. So you're going to have to work with these people to figure things out and solve complex challenges. Sometimes people need to squeeze more I/O out of a data set so that they get information in a timely manner. If this continues to run the way that it's currently running, it's going to take 16 hours. But because of maybe the weather challenges that we deal with, I need to have it done in 4 hours. How do we squeeze 12 hours out of a process? How do we get that more parallel across more CPUs, across more storage? There's all these things that we can do, but we got to work with other people to do that. I tell you guys often, as like a Linux engineer, we're building servers and standing them up to be fast and lean and security compliant and all these other things. But we widely don't know, as we first set up a set of servers, what they're going to do for the organization. That may come later, right? Your task may just be to integrate RHEL 10 because we know we're going to need RHEL 10. And then from there, we know, okay, well, generically speaking, we've got web, app, and database servers. Make sure you're ready for those. Okay, boom. I've got that tied into my the way that my Ansible playbooks deploy my servers and the way that they customize things as they come up. But then under app, we've got our dev and our prod. Dev goes to one data center, so it behaves a certain way and touches certain servers, and then maybe as we download code, some of you guys have seen how we check stuff up out of Vault and some of these other tools. So now you're just looking at all these different ways that your interactions with these people can be done better and more automated, so that nobody has to reach out to you. Everything just works, right? Create and foster partnerships with research at the company, wherever you're at, to encourage outstanding delivery of services. These kind of go together, right? This is a big one. Translate project deliverables, milestones, and timelines into predictable team outputs and tasks. This is a skill that you're going to learn over time as an engineer. But I will tell you, one of the things that I think you should practice early on in your career is outlining things. Like somebody tells me, Scott, I need to build a set of servers. And I say, okay, what are we building them on? Where are they going? What's our, what are we doing? I start asking some questions. And then I can take those and say, okay, we are building a set of Linux servers from some containers. They need to come up and do X amount of things, whatever those things are. And we can start to look at outlining all the component pieces that I'm going to have to build and make sure that the deliverables align with like the timeline, right? And then I can start knocking things off and handing them to different people on the team. This is also one of those things that comes up in like sprints and stand-up meetings where people will start to throw tasks on a Jira board or on a I'm a big fan of Kanban. I like Kanban boards. I think they work well for, especially in my type of work, like where it's blocks of work that get done interchangeably depending on whichever engineer's working on them. All right. You got to provide some consulting in the selection and purchase of hardware and software systems. So you're going to be asked things by management. You're expected to know things about hardware and software systems that are coming out, different versions of servers. So maybe you're working on some very specific like XE4000 Dell boxes, and you know that the 4800s are coming out in a few months. So you let them know, hey, they're not out yet, but the next version of this that we're going to should be this. And you start to build out that knowledge and keeping track of what you have so that you know where you can go to, right? Also, some of this stuff, this is stuff I don't necessarily like doing, but there's stuff that is very valuable in here as an engineer, is being able to sit with the vendors when they do their vendor presentations. Like if you're already working with Red Hat, they're still going to be giving you presentations on the new stuff that's coming out because they want you to know what's there and they want you to know that. So you need to, if you're sitting there, you need to understand what those tools are and stuff. They want to talk about configuration management. Every company that's worth its salt in the engineering space is going to do config management in some way. We hammer that pretty hard in the systems engineering course, or the security engineering course. Git, Jenkins, Ansible, Puppet, some type of thing to make sure that things are not changing off of the original baseline as you deployed servers, right? They want you to ensure the secure and effective operations of systems through compliance with whatever procedures and IT operating procedures that they have. So a lot of times you're going to have some standards that you have to follow for the government. And then sometimes you're going to have standards that you have to follow for maybe dealing with like credit cards. One of the big ones is PCI. Payment card industry, PCI DSS, is not a required thing by any government ever anywhere on the earth. But if you want to take credit cards, you will adhere to PCI. If you don't, they will not accept your credit card transactions from your organization anymore. And guess how well you're going to do if you can't take credit cards? Not very well. So PCI is one that you're going to run into a lot. Another one for operating procedures that we get a lot for building servers is CIS benchmarks. CIS benchmarks are huge in the industry for people. In the government stuff that I work in, we don't use CIS, but we use a thing called STIG. The STIG, which is the Secure Technical Implementation Guidelines. We probably run into those. I'd say there's an overlap between those and CIS at about probably like an 85%. So they're mostly just, they're not quite interchangeable, but they're pretty close to just being the same between the two of them on a lot of stuff. But you have to adhere to system compliance within the company. We talk about in the security engineering course what that looks like: technical, administrative, managerial, and then also physical controls. So it's kind of like the acronym TAMP, maybe. Technical, administrative, which actually are called operational and then managerial, procedural, and then physical controls, rather, right? Control Byte, you said you were just listening to a podcast today with Aaron Lippold. I don't know who that is. Oh, MITRE automation framework. Nice, nice. One of my professors in college was also part of the MITRE automation framework. Yeah, he was with the Air Force at the time, though, so I doubt he's credited with some of that stuff. But he had been working with them for a long time. He was an Air Force general, and he had been working with MITRE since the 70s. So that's interesting. He was a good professor. Now, from here, then we have develop, architect, and engineer systems and related application software solutions, including research projects. This includes monitoring for system issues, so up here, but even more around tracking issues that are coming, guiding project tasks through engineering processes, and ensuring standard methodologies are implemented continuously and consistently. So methodologies of how we do engineering processes, this is kind of like what I was talking about here, where I always do things the same way all the time. Everything I build is the same way. Everything uses the same exact template. I mean, it's going to sound silly, but I often say I can't believe that they, I don't know, I just can't believe sometimes that they pay me what they do to do the same things over and over again. But here we are, and here you can be as well, I think, if you spend time doing this stuff. Managing your backup services, like, look, rsync and SCP are cute. They're great to start with, but then eventually we got to put on the big boy pants and do backup services with like a Bacula or some kind of tape manager type, some type of tool. I like Bacula because it works with all kinds of different things. But what's another one that's really big is what is that tool for backup? Yeah, I mean, go pick one, right? There's a bunch of them that are out there, but you need to have things backing up your systems. Even better as a maturity in your organization, let me tell you this: managing backup and getting stuff off your systems is great, but having your systems be stateless and ephemeral, and as part of the engineering process, all data that are ever processed on your system are automatically backed up to the network, and then that's backed up. So what I mean by that is, like, if I take one of these servers here, right? Let's go to like Rocky 19. Rocky 19, you've done great work. We go look at you. Everything that we care about that might be persistent on here is out here, and I can reboot him and rebuild him at any time. I just rebooted him. He's going to go rebuild himself according to my policy inside of my home lab here with Rocky, and with Werewolf. He's going to build himself back up, and then he's going to reconnect to all the data that are important in my system. He himself in this TempFS system did not keep anything of importance, because that's not not a very mature system. So managing backup of services, there's also a certain maturity to understanding where your data are being held, and then what is something that can be rebooted and destroyed or rebuilt, and then there's also the thick nodes, the stateful nodes, not stateless nodes like mine, but there's different considerations here between these things. Okay, troubleshooting and resolving system problems quickly and effectively. So this is the idea that we can walk through the same thing the same way and figure it out. And the fact that we're driving towards a solution, we're not just randomly driving and crashing into things and messing stuff up. I do have some of that in this other talk over here where it's like, do I have it in here? No, it's not in here. It's in one of my other talks. Hold on, I'll pull up the other talk real quick so you guys can see. When we troubleshoot, do I have security? All right, I just got to pull a new one up. Hold on. Sysadmin. Where's that? All right, got to go find it. Let's go down to Linux group. And then we go down to presentations, and it's in my Linux sysadmin one, right? So this one's been updated a few times, but when we talk about driving to a solution, right, what I mean by that is this. How do we troubleshoot? How do you troubleshoot? Do you have like I just like think about this for a second. If you say, Scott, I want to be a sysadmin, I want to eventually be an engineer, and I say, what is your troubleshooting methodology? Just outline for me a little bit your troubleshooting methodology. If the first thing that comes to your head is like you know, I just look for what's wrong. Well, that's pretty wonderful. That's not terrible, but that's not like enterprise grade, right? Enterprise grade is more like this. This is the way that I learned in the Army right here. Troubleshooting theory. You always follow at least this pattern. Identify a problem and its symptoms, establish a theory of probable cause, test your theory to determine the cause, establish a plan for resolving the problem, implement it, verify it worked, document everything. This is a high-level way to always drive to the right answer. You loop through some of this if there's problems. This also looks like this if we were to look at it visualized, right? This is just the words, but this is it visualized. We identify the problem, we start to gather information, we look for symptoms, we question the obvious, we follow the OSI model, we test our guesses, do we confirm yes or no? Do we give up at some point, or do we keep going through the OSI model until we get everything done? Do we give up and escalate to a higher engineer, or do we escalate to our vendor? And then we stop, we drop out of this. Or do we confirm and say, yes, we plan steps to fix the problem or escalate, verify that it's working? Is the problem solved? No, we got to go back up and start playing again. Start spinning up here. If the problem solved, yes, could this have been prevented? If the answer is no because it's a hardware failure, then we document the findings and go. If the answer is yes because it was a human error is always the thing, right? Not always, but a lot. Then we take preventative action to put guardrails up so the human can't do that problem again. Maybe one of the things that we've done is we've masked commands. So the command isn't actually the command. You're actually running a script that will run the command only after you acknowledge that you know what you're doing. Or one of the ones that I used to do, this is actually kind of funny. Before you could run my Ansible playbook, I had a survey that would pop up in. So that's what it's called. It's called a survey when you pop something up in Tower, but now it's Ansible Automation Platform. And what I would do is one of the fields you had to implement, even though it wasn't going to be used in the playbook except in the log, was you had to put your change record in there. So then I knew who executed it because it was tied to your user. I knew that you had a change record or you had to fake a change record. And either way, I didn't care because that was going to go to management if somebody did something and broke shit, right? Because like if they were doing stuff outside of the normal window, that's on them, not me, right? Document findings and outcome. Anyway, so that's that. Troubleshooting methodologies have a good starting point, a process, and an ending point. Assume nothing, believe no one, check everything. I think those are very valuable in troubleshooting, right? But anyway, so troubleshooting, create a problem statement. Use I love the use methodology, utilization, saturation, and errors for systems. I show you guys this all the time. And then we step through the OSI model, right? Like if I can ping a device by its IP address, I don't need to go make sure that it's on and the network cable is plugged in. And I don't need to make sure that the cable's got the right color and that I see a link light on it because I was able to ping it, right? All right. Anyways, then there's some other ones, and anyways, there's all that. We're not doing all that right now. I'm just telling you guys that you need to have a troubleshooting methodology if you want to be in it. If you tell me, Scott, hey, it's time for me to stop being just an amateur and playing around with this, and I want to get into doing this professionally, you've got to build your troubleshooting skills. That's it. That's like full stop. There's a tool. There's a good one to study. It's called Kepner-Trago. That's pretty good spelling. It's pretty close to the right spelling right there. Kepner-Trago is a methodology for incident calls and bridges and that kind of stuff. It's pretty good. They help you to frame and drive to a good answer. And then this one is like, make sure you're doing the stuff. Make sure you have the core values and all that kind of stuff. All right. So this is going to scare people a little bit, but remember, this was a senior high-performance compute engineer. So this was actually one that I pulled from a company. Their minimum qualifications. I said koala. Anyways, all right. Their minimum qualifications are a bachelor's degree, maybe a master's degree or a PhD in the space, right? Sure. But they want you to know, look, this is where, like, we can't help this if we're not going to do college, sure. But Do I have a strong knowledge of enterprise Linux? Can I show a Red Hat cert of some type, and there may be a Red Hat shop, right? Um, do I understand server storage hardware? Could I walk in a data center and pull something apart and show the component pieces of it? This is something that you can't get except having been in the data center and doing some of that stuff, right? But do you understand that stuff, right? And this is some of the stuff that we, again, this is one of the reasons it's senior is they want you to have this stuff. And then some of these different tools that are very big in high performance compute. So hardware and software, InfiniBand, that's a very specific type of networking that we use often. It's by NVIDIA. NVIDIA bought Mellanox, who invented it. So NVIDIA runs InfiniBand. A lot of people, when people tell me like, oh yeah, NVIDIA's got the high performance compute GPU space on lock, I'm like, yeah, no, they do, but way more than most people think. They also have all the networking. If you go to the top 100, so there's a site called the Top 500, right? You guys have never seen this? Top500.org. This is where we go to race our supercomputers. I can promise you right now that in the top 100, 95% of them are 95 of those 100 are using InfiniBand. What, right? Without even looking at it right now, I know that's a fact. Right? Here's the vendors that have built it, but under the hood, all of these are NVIDIA, using all of the different stuff. But anyways, here's all where the countries are and all that kind of stuff. You can go look at all that. There's a lot of really good information at Top 500. You can see old historical data and that kind of stuff. Slurm is a scheduler. Other than Slurm, they're using Slurm because that's what the company actually uses. PBS is a big one as well. That's a job scheduler. There's one called LSF, and Platform LSF are kind of big. Those are IBM technologies. Lustre is a high-speed storage. It's the OpenSFS Foundation. So if you go to this thing, OpenSFS, right? This is Lustre, and it's the Lustre file system. And you go read about that. And I'm a big fan of Lustre. I've been using it since 2008. So Lustre is a good tool. It works well. It's very fast. It is a distributed file system that looks like this. And I've got a talk where we talk about it a little more. But if you go to the OpenLSF, then you go to their, I'll drop you guys down there, Lustre Wiki. Here's their sysadmin guide. This is the basic guide. And then right here should be, no, we want the PDF. Where's the PDF at? Yeah, Lustre Architecture PDF right here. So I'll link this PDF to you guys if anybody's interested. But again, this is very niche. This is like if you want to get not just into Linux, but you want to do high performance compute as well. And this is the thing about it. This is where it gets its value right here. This is where Lustre really, all your clients can be down here connected to your high speed network. And then they are checking in. There's two things that are happening. They're checking into the cluster over here with the MGT so that they can talk to things like they should. And then in this case, there's two MGTs, and they are touching the data here. But then when they want to gather data, they come in and check their metadata targets. So they come in and check in on the MGT, and then they talk to the MDT to get the inodes and where things are at. And then they go out and find those pieces across multiple different servers and multiple different backends and pull that down at very high speeds without ever having to check. This is a lot like if any of you were younger and dealt with card catalogs. This is a lot like the card catalog over here, especially the MDT, the metadata information. And then they go and they grab the information directly from the shelves, if you want to think of it like that, without ever having to talk to these slower, well, potentially slower devices over here ever again. And then they're redundant, so if I kill one node, or if one node starts misbehaving, the other node always in a pair. These are your object storage servers that go back to your object storage targets. They will have the ability to do what's called stoneth, which is shoot the other node in the head and kill the other node and take its resources over. It's actually really funny. But, well, it's not funny when it happens because it slows things down, but it's really funny that it does happen, and it's called stoneth, and it's hilarious. All right, but anyways, there's all that. This frickin' thing. All right. RDMA is the ability to do memory directly to the You get to bypass all the kernel filters and go directly to memory over the network. So RDMA is part of the technology underlying InfiniBand. Let's go back here. There's a pretty good, remote direct memory access. And there's a pretty good diagram that always gets pulled up here. You might have to look around for it. But RDMA is the ability to go directly to the memory of the system while bypassing the kernel and the kernel filters. And it's very fast. And you can read a little bit about the support for it here. It used to be, back when I first started using RDMA, the only OS, there were two OSs that had support in the early 2000s. It was SUSE, right, which was SLES. And then it was RHEL, but RHEL was being repackaged as a thing called Oracle Linux. Still exists, but back then only they and SLES had the drivers to do RDMA correctly in like the 2009, 2013 time frame. So you can go read about that if you want. Lots of stuff there. That thing. All right. And then Weka. Weka is this super high-speed file system now that we're using over it's container management on the box. It's a really interesting way of doing things. I deal with a fair amount of Weka, and it's pretty fast. It sets up multiple UDP connections on your system and then can communicate with every other device that is, again, very distributed, much like how Lustre is, except they're using different types of communication over UDP. Weka's fast. Weka and Lustre, their bottlenecks are almost always the switching environment that you're in. That's how fast they are with disks and the numbers of clients that can get in them and the optimization of them. The thing that almost always slows you down in these is how fast your switch can handle the traffic. Isn't that funny? They're so powerful and they're so well optimized that your switching hardware, which is like, I mean, that's unheard of in any other context, right? Like, would you think that your switch was slow in your home lab? Oh, hell no. How could I even saturate the switch if I wanted to? I would saturate all the NICs in my environment first. But with Lustre and Weka, since you're talking thousands of clients sometimes, those thousands of clients want to get out to the individual OSSs, and the switching backplane can't handle it. So you can look at that and look at how we mitigate that, because there's a lot of ways we mitigate that. All right. Related technology central to the team's work. So you just got to know a lot of stuff. That's always true, right? If you want to call yourself a senior, you got to do a lot of that stuff, right? You need to understand your configuration management. Oh, wait, we were already past that. We were here. Configuration management tools, virtualized environments, tuning and maintenance. How do we tune out an OS? How do we make an operating system do what we want more efficiently? Excuse me. Strong working knowledge of system design. Well, for that, you just have to get involved with system design, right? Look at blogs and look at ways that things have been published. There's some good Weka stuff out there. There's some good Lustre stuff. There's good stuff for all of this as far as designs go, and to at least understand what's going on, right? I need to add some of those and update my... I have a talk that I did on high performance compute where we kind of touch each of these pieces, but all right. You need to be able to get a security clearance, so that might knock some people out. That means you can't be out gambling and moving houses every 3 weeks. That kind of stuff won't fly. You got to be able to do Bash and Python. That's almost always going to be there. They want you to have some cloud native stuff, OpenStack, VMware, right? And then they want you to know some Jira and Confluence. So this is going to be working with the team and using Jira, Confluence, and different documentation type stuff. So that's minimum qualifications. But from these, I then distill down to our reasonable or our responsibilities and competencies questions and matrix. And these are the types of questions that I ask the engineers in a technical interview. All that other stuff I don't go over with people, right? That would take way too long. If I only got you for 35 minutes or 30 minutes in an interview, because that's typically all they give me in a technical interview, these are the types of questions that I ask right here. I say, please describe the Linux booting process, preferably on a RHEL CentOS Rocky box. How would you troubleshoot that process? And I get all kinds of different answers from people for that. Like, this is a very open-ended thing. Let me grab some waters, hold answer this different ways, right? You might start talking about the hardware. Hardware comes up, power on self-test, beeps and smoke if there's problems. We go start walking our system bus for all of our bootable devices and our boot order, if that's set in BIOS, right? From our boot order, we find a master boot record and boot from it. Hold on, wife's calling me. All right. So, somebody might tell me about that. And then how would you troubleshoot the process? You get to a kernel, the kernel starts to come up, the kernel does not finish coming up. Maybe the kernel panics, right? What are you doing? Like, what are you gonna do? Are you gonna restart the kernel and go to a safe mode? Are you gonna restart the kernel and change the quiet off of the command line so that you boot in a more verbose manner and maybe you can see what's happening? Are you gonna look at what the last thing that happened before the kernel panicked? One of the things that very common before a kernel panic or dropping into like a rescue shell is almost always something to do with an unmountable, you're trying to switch root to an unmountable device or something. That's very common, especially if something's recently changed or if something's using disk paths that are not always going to be set correctly, things that are dynamic and change, right? So we can check that. We can go look at what those things are and we can boot up into a different system and look and mount the switch root, right? Or mount the system and then change that if we need to. So this is something that I would expect somebody who's been doing Linux for a while to know how to do, right? And I not just know how to do it, right? Like I've never in a technical interview sat somebody down and asked them to get their hands on the keyboard to do it. I'm convinced, and maybe some people don't agree with this, but I think that it only takes a few minutes to understand if an engineer is working on the same wavelength as you, right? Like, and if somebody's done these things, the way they're going to talk about it is going to be like they're talking about an old friend. Like, oh, I've done that before. Yeah, let me tell you about the time I booted up a server and it didn't, right? And they're going to tell you things about it that you couldn't just read in a book, right? There's a difference between, like, if you guys have ever seen the movie Good Will Hunting, there's a great example of this. He talks shit. He's really good at like talking shit and hurting people's feelings. That's like Matt Damon's character. He's really smart, but he's also an asshole. That's his character. And he gets under Robert whatever his name is. What's the comedian that was playing the guy? Robin Williams, right? He gets under his skin. And then Robin Williams, when they're talking later, he's like, I got you about that when I said about that wife of yours having cancer or whatever they're doing, as they're going back and forth. And he goes, you know what? I thought about it. You could tell me everything about the Sistine Chapel and this and this and this, but you've never been there. You don't know what it's like to actually stand up and look. And you don't know like the smell of this and that. And he like basically called him a snot-nosed punk kid is what he did. Well, where I'm going with that is, not to say that about other engineers, but what I'm saying is like an engineer that's done this is going to talk about it in a way that he can't read in a book. He can't, you can't, there's no substitute for experience in this, is my point. And then in this case, like, how do you automate something in Linux? What tools do you use to execute something at a specific time of day? There's two answers. You could say I use Bash and I use cron, and then you just sit there and look at me and it'll be like, well, that's not super great, but maybe tell me a little bit about what you've automated or something that you've done and why you've done it. And I do think that there's a certain amount of maturity where somebody's going to say, oh yeah, I've done this and I've done this, and my team was having a problem with this, so this is the way that I solved it or whatever, right? And then this is another one that is very open-ended. How do you harden a Linux system? What are the high-level steps? Can you tell us about a time that you've hardened a system? So what do you do to harden a system, right? What do you take out all the software that's not needed? Do you start with a basic disk layout and like everything about like a STIG or a CIS benchmark so that everything falls into place? Or do you focus more on making sure ports are closed and only the software that's supposed to be on there is? And then tell us a little bit about maybe the time you've hardened a system, right? What I wouldn't expect there is maybe somebody to tell me like, oh yeah, I went to a set of servers and just started cleaning stuff up, because that's not really enterprise level hardening. That's kind of like admin stuff. That's what would be more of that type of hardening would be maybe building something from scratch and then deploying it for multiple, thousands of systems or something. IT DevOps, thanks for the follow. Hopefully this stuff's useful to you. We are talking about high performance compute. This is technical questions that I give people when I do the technical stuff, right? We get into identity and access management and how do you allow other systems to be trusted by your Linux system. Nowadays, a lot of times this is tools like SSSD or identity IDM with Red Hat, right? Those kind of things. We used to use Kerberos, so people that want to talk about Kerberos and Winbind, those are ones that we can talk about, right? As far as understanding how those kind of things work. And then another one, this is one, like, can you tell me the RAID levels? Now, this isn't me just trying to, like, hammer somebody. I just think that somebody that's built a lot of systems is going to know what the RAID levels are. They're going to know 0, 1, 5. If they haven't done a lot of storage area networking, they might not know what 6 is. 6 is a little different. But maybe they would at least know 0, 1, and 5. And they can tell me a little bit about how they're used in storage systems, right? Especially, again, this is a senior role. So I would expect that to at least be some level knowledge for people. This one's big. What type of operating system updates have you done? This isn't just like your desktop clicking next, 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 and finish. This is like a process for enterprise upgrades, right? This is something that I've built a lot of my career on, is building out tables and moving stuff forward in a controlled way that keeps all the ships upright so that the systems keep working, right? Can you describe process you've used? How did you ensure different environments stayed in sync? What tools did you use for that? Right, that kind of stuff. And then this one goes back to our troubleshooting thing. What troubleshooting methodologies have you used? How would you solve some problem? And I might not like expect them to just, like, I might not expect them to like read these off like a robot or something, but I would expect it to sound something like this, right? Because this is a pretty solid way to get to the right answer each time, right? So that was our troubleshooting theory from earlier. So, all right. So then, here's an example and how it might be filled out. But anyway, so that was, we were talking there about maybe some, where was that? Oh, then I was going to do this one. So what have we done? Yesterday we did this self-assessment matrix. And then we got into like keeping yourself ready to do engineering and how to get into engineering. Then we just looked through some of the maybe technical interview questions that you might run into. And we didn't go into yet the Linux sysadmin stuff. That stuff's all up in the Discord. You guys can look at that later. I'll probably finish up this last little part and then I'll probably be done for the night. But I think that this is a pretty good kind of intro to how you would get in the industry if this is something that you want to do, So let's go look at this one. These are some soft skills, soft engineering skills, day in the life, right? Diddle, day in the life of an engineer. All right. So here's some things that I kind of think that engineers don't get taught maybe in college, but it's actually funny because I teach this to my college students. So then it's the opposite of a self-fulfilling prophecy because I actually make it not true by teaching my students. But anyways, let's go here. What are stand-up meetings? Stand-up meetings, typically, this was much more when we were in the office, but they should take no more than 15 minutes and they should focus on only 3 topics. What did you accomplish yesterday? What are you working on today? And what blockers do you have for any task? What this means is if you've accomplished something yesterday, it can move to the next part of whatever testing or getting integrated into any type of workflow, and you could start working with it, right? So what you accomplished is very important because it helps everything move forward. What are you working on today is very important because now this is about what do you think you should be doing, and if your manager needs to redirect you, they should be able to do that very quickly, right? Move you on to something else and all that kind of stuff. And then what blockers do you have for any tasks? Maybe you've sent an email to the network team. You sent it on Monday. Now it's Thursday. You've sent a follow-up, and you need to just toss it over the wall to the managers and let them have at it because it's not an engineer's job to go fight with other engineers. You may think that early in your career, right? You may think it's time to have like put your fists up and do some 30 style boxing with somebody. That is not the fucking point of engineering. The managers need to go deconflict things between teams. And I mean, in my case, I will almost always throw that up immediately. Like if I can't get a hold of somebody and they don't get back to me in a day or two, and they're like a real blocker for something, I'll just let somebody else know and I'll go about doing the other stuff. I don't let stuff like that slow me down, right? Nick Hill over on YouTube, he said, "Hey, I want to get a job in the cloud and DevOps. Is it possible for new grad?" I think it's possible to do all that stuff. Sure. I see people getting those jobs left and right on LinkedIn and my old college students and stuff. But what the idea of this whole talk here, Nick Hill, and you might have to go back to yesterday's talk, but it's like, what do you want to do, and then what are your gaps to get there, right? You have to figure out, like, if you say you want to get a job in the cloud, do you want to work with AWS? Do you want to work with Azure? Do you want to work with Google Cloud Platform? Those are very big differences. There's, I would say, focus on one, and then do you want to work for like government contract? Do you want to work in the sciences? Like do you want to work for a local college? And then find jobs that are doing the things that you want, and then start to align yourself to those job duties, right? I have over here a bunch of job duties that we were going through the other day. These are from real jobs, right? And we were going through and we were writing up what we needed to know about these different things, right? This was a thing that I was doing the other day. These notes are up in the Discord too, right? And you could start to walk through and figure out what you did or didn't know and what you needed to learn and all that kind of stuff. But with stand-up meetings for these, there's 3 tasks you should do. Now, there's another thing. People are going to constantly call what they're doing agile, and almost universally, the first second that a manager decides to do agile, everything they do is not agile. There are 4 tenets, 4 points that form the basis of the agile methodology. These are them right here. This is so bad. I need to add the little image that I made here. I made a GIF one time. It's that little Cash Money dinosaur. You guys ever seen that dinosaur that says that wasn't very Cash Money of you? But he says that wasn't very agile of you? Because every team I've ever worked on that wants to be agile doesn't do these 4 things. Individuals and interactions over processes and tools. Working software over comprehensive documentation. If we can etch something together and we can get it working while we're sitting in the meeting talking about it, that might be the path that we take in an agile methodology. Customer collaboration over contract negotiation. We don't just sit there and smack the contract and say, you said you'd have this done by this. You go work together, right? Back to my point earlier about people that are blockers. I try to work with people, right? Like when we were in the office, I'd walk over and talk to the network guys. But if I couldn't get something from them in a certain time, then it is time to go to the management, right? I'll try to work with anybody. That's one of my things that I've always been good at as an engineer is I work with most people well. But customer collaboration is important. And then responding over change, over following a plan. If we find a better path or a new thing comes out in the industry to go to, it's not that we're chasing the rabbit. Chasing the rabbit's a different thing, and it's a whole different problem in engineering. Chasing the rabbit means you always are trying to do the new thing, and you never get anything done. If you guys have ever seen a dog, so it's a derogatory term by Japanese companies towards American companies. It's called the Americans chase the rabbit. And have you guys ever seen like a dog that hasn't hunted rabbit before? Try to hunt a rabbit? It's a pathetic thing. The dog gets tired after chasing about 14 different rabbits because it just goes after the next one that shoots out of the next bush. And rabbits are really good at just running into bushes and staying, and the next rabbit goes off and tires the dog out. If you've never seen it, it's a pretty interesting thing. A good dog will just chase the one rabbit until it gets it, right? If you ever go hunting, you'll see that. But where I'm going with that is these 4 points form all this agility. So down here, ECB or CAB meetings, this is big. This is a soft skill that I don't think we teach enough in engineering, but it's engineering control boards or change advisory boards. You'll hear them called different things. But configuration management is really something you have to follow. We build systems, we push them out into the environment through our CI/CD pipelines, and then we hope that during their life cycle, they are only changed in appropriate ways so that they properly work the ways that they should, right? When you push, I tell you guys this, like, go push 10 servers out into an environment and then come back a day later and run a script on them to see how similar they are. They are all different. People have changed things. Dev teams have put more stuff on one server storage than others. Like everything's different, right? This is just how servers go. They slowly drift apart. And we need to make sure that we do configuration and drift management in our systems. That's a thing that we talk about in the security engineering course. So all changes to the environment must be approved by ECB or CAB. And then changes must have the following information. What's the complexity? Is it a simple change? Is it a standard change? Standard changes can sometimes just be rubber stamped, but is it something like I'm patching everything in the environment and it's going to go and roll through, and update the kernel and we have to reboot everything in the environment? That's a pretty complex change, guys. Like the worst thing for a Linux engineer is when we have to reboot boxes. And we have to do it for patching reasons and such, but we hate it, right? Because in general systems, we hate taking them down. They work fine when they're running, but then when we want to change them, sometimes we got to reboot them. When we do that, I often tell people, nobody runs Linux servers just to run Linux servers. There's no company on planet Earth that got to 1,000 Linux servers and then went and told all their buddies, hey, we have 1,000 Linux servers running. What do you have? Not like one of those American Psycho things where he's like looking at their card. No, there's services that are running on there. Your Linux boxes are databases and they're app servers and they're front-end web servers and they're all these different things, right? So systems affected and their associated downtimes are things that you have to understand by either reading the documentation or knowing what teams are owners of things. And if you're going to change a lot of systems, you need to document what services are affected. This is very important because it may add to the complexity of a change. If I'm taking a front-end web service down, right, and I'm taking all 10 of its back-end servers behind a load balancer down, now I need to think about how I can roll through them so I'm only taking maybe 2 down at a time. This is also something that's made simpler by Kubernetes. If you guys have ever done like my Blue-Green or my Canary Labs where we move a service forward to the new set of server or a new set of back-end pods, it's super easy to do, right? But the complexity of like system changes will change based on what's on top of that. If it's a database server and there's an active primary and a backup database that's like a read replica or something, well, do we have to fail over to the read replica and make him the primary so transactions can continue to exist inside of our company? Or do we take the whole database down for a certain amount of time and eat that downtime? Do we understand the implications of those things? That's the complexity of the change and what's happening. Expected downtime. Do we not expect downtime, but could it also happen? Like we've tested this change 100 times, but it has failed once. We just had this happen. We just had this happen on a project that I'm on. They were changing out we had 2 OSSs, so object storage servers, and somebody pulled the wrong controller card out of one of them and took down both sides of the path and caused us to fail Lustre on a very big cluster, 2,600 nodes. We had to fail over between 2 different states. We had to fail over to the other data center because of what this person did. Now, this was a very routine thing. It had been done many times before. There was no impact downtime ever expected unless you pulled the wrong card out, and this guy did. Now, this actually leads into this next one. The guy who always has performed those changes was on lunch. So they had one of the junior guys do the change, and he messed it up. We found that out a week later. We just found this out actually like 2 days, or it was Friday, I think we found out. So it was a week after. It happened on Monday last week, and then it all the way up to here, Friday, we found out that it was the wrong guy doing the change. If the right guy had at least not been in the other part of the facility munching on a sandwich, he could have stopped the guy from doing the wrong thing, but he wasn't there. So we took performance hit downtime against a real big system. Again, we had to fail over from one cluster of 2,600 nodes to the other data center because of this. That's a big impact, guys, right? That can affect like bonuses and like company performance hits and stuff. Anyways, has the change been performed and tested in lower environments? Yeah, sometimes they are. Yeah, it was a pretty good sandwich. Well, that sandwich cost somebody like $1 million, probably 10 million. I don't know what the penalties are, and I don't think the penalty will be triggered just by that one event. But if we were in a worse stated condition, it could have been. Rollback plan, has it been tested? Can we go back? Is it a hardware failures have no rollback, guys. I just need you to know if you have a disk failure, right? And you're like, hey guys, in this RAID 6, we've got a RAID 6 8+2 system. So there's 8 live disks and 2 parity bits disks, and when one of them fails in the 8, one of those other disks come active. So now you have one parity bit and then one that's failed out, and you pull that disk out. There is no rollback plan to put that disk back in because it's a failed device. So sometimes with failed devices, especially in big storage area networks, we don't have a rollback plan. The only thing we can possibly do is put in the new one, and if that didn't work, put in a different new one. Those are our options there. There's no option to go back to a failed disk, guys, right? So that might sound silly, but it does matter in your change management record. There's no rollback plan. It's been tested. We have a mean time between failure on our disks of about 3.5 years, and in a 2,000 node cluster, that means that we expect between 4 and 5 disks per day to fail, and we do not have a rollback plan. We will constantly be changing disks for the rest of the time that we run the system. That is a very common and true. All of those things I just said, they're not made up, right? So we need to understand these things. This is how engineers talk. Change must get following approvals before going to board. Yeah, whoever owns the assets. I tell you guys all the time, as Linux engineers, I build servers and I push them out, and I am never in charge of those servers again, guys. And then sometimes I also put a hat on to be a systems administrator, right? A Linux systems administrator, or my junior admins that are doing the admin stuff. They don't own the servers either. They're maintaining them, but the people that own the servers are the dev teams and the production teams that own those services that run on top of the Linux boxes. Does that kind of make sense? So if I'm going to take down somebody's web servers, right, and I'm going to roll through them, his or her team needs to give me approval to do that work, and then they probably also need to be there on the call that night. They're going to become like an interested party to the call. They're going to become a dependent party, and we're going to have to put them on with tasks to check their applications as we roll through the change, right? So that's what an ECB looks like. And then we go more into that in some of our other talks and stuff. But I think this is a thing that you need to understand if you want to be an engineer, right? ECBs and change advisory boards. All right. So I need to update this one. This is a new one that I just added. So this is empty. But the idea of updating dev versus prod kind of comes down to this. I think I have it in meeting notes over here. When I was drawing these out for the Linux security engineering course, we were doing, so there's this right here. Where's my meeting notes? Yeah. So right here. Let's say you were, you have some risks, and they've been, so your patches are coming in from whoever your vendors are, Red Hat or Oracle or whatever, Microsoft, whoever, and you're going to download those into your centralized patch management system, right? By the way, I have these are somewhere, but I post them up here if anybody wanted them. So here's our centralized patch management system. This is going to lock in typically some day of the month. I like using maybe the first day of the month. And it's going to lock in all the repo content. So now it's internal to me and I control it. I can then now release that through my dev, my test, my staging, and then maybe my production environments. And I tell you guys all the time, between production and dev, you could have, I've been in an environment with 17 different environments between the true start and the production environment. And you say, that many? Yes, we needed that many. It was a big government contract that we were working on. This was at Lockheed many years ago, and it was a big government contract where we were the factory to a government site. And we deployed things and patched and worked through things like this before it went out to the government site. We deployed whole hardware bundles, whole racks and multiple racks of servers for these downstream processing of satellite data, right? So anyways, you download it, you release it to just your dev environment. You do some testing, you do some validation. There's different types of testing you do. You might do regression testing. You might do smoke testing. Smoke testing is where you turn something on and make sure that the smoke doesn't come out of it, right? Because if the smoke comes out of it, it's not working right. So smoke test, regression test, make sure that it works with all the past versions. Maybe you're updating to a new version of an API and need to make sure that you still support the old application code. One that's really big in some of these is when people will make schema updates to the database, and then they have to at the same time update the app so the app is touching the database, or the app needs to have been resilient enough to still work with the database on the new schema. And those two things between those teams, I've seen a lot of conflict between teams over the years where database teams and app teams struggle to get their schemas correct on updates, right? And maybe you standardize that you can only make so many schema changes per year, right? And it can only be so many of those. So we move through the dev environment, we push those baseline patches forward to the test environment, and then staging and prod and all those kind of things as we move forward. Okay, we won't go too much into that, but that's one of our course things for security engineering, right? We come down here. This is a huge one. Hey, Robodom, how's it going? Thanks for the happy belated birthday. I do appreciate that. Yeah, my birthday was Saturday, 44, big 44, right? As my friends were saying, because I'm a little younger than most of my friends, and they were all saying you've achieved your mid-40s, and I think that's hilarious. But let's talk a little bit about something that comes from ITIL. Yeah, 44 years of awesomeness, Robot, I'm sure. Yeah, that's pretty good. But we'll talk a little bit about fit for use and fit for warranty. This comes from ITIL management, right? So ITIL is like IT. What the heck is that? I forget. I'm an ITIL version 3 certified, but I don't really put it on anything because they're up on 4 now. But fit for use and fit for warranty looks like this. So fit for use is the idea that the system does what it's supposed to do. In an engineering sense, this is what we call functional testing. Can I check off that this is so we say that we needed a web server. The web server needed to operate on port 80 and port 443, right? Like, let's say that. I can go to that web server. I can ping it via its IP and its DNS name and check that off. It's got a DNS name on our network that matches with its IP. Cool, check it off. I can curl port 80 and port 443 and see some kind of open, situation for it's serving some type of thing, so I can check that off. I can validate that, with fit for use, it's just checking things off. It is a web server. It is doing this. Maybe it serves out a basic Apache page. Sure, it's good. It's doing all those things. But fit for warranty, I always say, does the system do it as often as it's supposed to? It speaks to the stability of the system. Or fit for warranty, I like to tell people, this is the ability, are you going to bet your weekend on that thing not falling over? So what this is, okay, we determined it was a web server, but now maybe we use this tool there's a tool called K6, or Burp Suite will do it too, where we just make 1,000 connections to a server. And on that 1,001st port 80 connection, does the server just fall over? Well, that's how the server's fit for warranty. Does it do it as often as it needs to? Like, if you think of a warranty for a car, they're warrantying that every time I turn that key, that car is going to turn on. And if, one time I turn that key and it's only been 2 months and the car doesn't turn on, well, that means, and let's say it's the battery that's dead, well, there's something wrong with the battery, and if there is something wrong with the battery, they're going to replace it because they have warranted that battery was going to start maybe 5,000 times or something, right? So fit for warranty is not how the thing is supposed to work. Fit for use is how a thing works. You do check boxes as engineers, you're happy. Fit for warranty is how does it operate in the wild. Once we release it and that 5,001st connection happens to that server, does it serve or does it give a 400 error or 500 error for some, what different types of errors might it throw, right? Some people might call fit for warranty testing. The types of testing that we call this is functional testing for fit for use. Functional testing would be maybe you hit an API and you walk all the system bus and make sure everything does what it does. And then fit for warranty is more of like putting it through the paces, seeing how it operates as you have multiple connections to it and as you check for different paths and all those type of things. So these are the different ways that we kind of use fit for use and fit for warranty. Fit for use is, does it meet the minimum, what we call a proof of concept or minimum viable product? And then fit for warranty is what I always say is, do you bet your weekend? Do you bet going on a Saturday night to the movies without getting a call out? let's say you're the on-call for this service. Do you bet that on this system? That's what fit for warranty is, right? Does it work as often as it needs to? So, all right, those are my thoughts on that. And then this one, I learned this in college from a master's level. The guy who taught me this, he works over at Honeywell. He's got about 30,000 people under him over at Honeywell. And this is what he taught me, is when you start to present information to people, right? Like I'm going to tell you about a change, right? Change management is its own, there's a whole thing of engineering on change management. But when presented with change in an organization, people always ask one or both of these two questions. How does it threaten me, and what's in it for me? How does it threaten me? It's going to change the way I log into Linux servers. I don't like it. What's in it for me? It's going to make my job a little easier. How does it threaten me? I can't just do the same things I always did. Now I got to learn this new tool. Oh no. You hear that a lot in like school districts. Like teachers used to always complain about shit like that, right? But people always ask this. And if you know that that's going to be what people want to hear when you're giving a conversation or a discussion, then you need to think about what's in it for me and how does it threaten me? Because this is the thing that people will not, no communication will happen. Nobody will have any understanding of what you're talking about or even listen to you until you address those two things. This is really important. If you're talking to like 1,000 people in a meeting, biggest meeting I've probably ever talked to professionally is probably about maybe 250 people. And I just, if I'm telling them about some change that's coming, I think about how it's going to affect them. And I put that stuff all up front because then everything else comes from that, right? Every other part of the talk comes from that. All right. So, yeah, I even say effective communication stops once people get scared and can't answer these two questions. Have you guys ever worked somewhere? This is big in IT. It's happened a lot even before COVID, but it's been big since, where like everybody knows layoffs are coming and like nothing happens until that freaking meeting. And people then, once they know if they're getting fired or not, then work starts happening again. And people stop sitting around and being scared about things. This is just the behavior of people. This is not just this, but how does it threaten me and what's in it for me? All right. Presenting data. This is what we were talking about earlier. I learned about this this was also in a master's program. There was a mechanic that had built a whole bunch of, he was just this dude that ran like a little shop, and he started his own little mechanic shop in California. And when they went to him, it was a little later on in his career. He was not super old, and he had built this whole chain of automobile shops, right? So he had this whole chain of them, and somebody asked him like, "What's your secret? Like, do you give the best rates?" And he's like, "I don't necessarily have the best rates." And they're like, "Do you give the best service?" And he's like, "Not necessarily that either, although we try all that stuff." But he gave this quote, and this has always kind of stuck with me. He said, "It doesn't matter how long you've been in business. People will judge how well you can rebuild an engine by how clean your bathroom is." And he made that so like when people would come in and they would check out his shop to drop their cars off, he would make sure that they were comfortable in the little front area. And that was his, if you wanted to ask for some secret of some guy who just built a bunch of shops and ran them all up and down California, that's what he did right there. Was he determined that he would make the presentation of his business one of the most important things. So this is why I say it's so important. As engineers, we deal in truth and we deal in troubleshooting and finding the right answer to things. So what we do is very important. This is what I showed earlier. Calibri, look at this Calibri body. This is like the worst output I've ever seen from a terminal. Been doing this 20-something years, can't read that at all. I know what this says and I can't read that. But down here, that's the way it comes out of a terminal. That's beautiful. That's Courier New. Courier New is the way I always tell junior engineers to send stuff in emails. It's monospace, everything will fit. And actually, that might not be monospace, that's just block. But the point is, it's readable. It's got all the spacing correct, right? Whereas this right here with Calibri body is terrible. I tell people, if you're going to send that, why don't you just like send like a picture of you flipping them off? Because that's what you're doing when you send that right there. You can't read it. It's unreadable, even to a sysadmin or an engineer, right? So don't do that, right? If you're going to present data to people, present it in a way that's readable. This next one, this is a real submission from a student one time. Every single thing on this page is correct right here. But it's a monstrosity. You literally can't read it. I might as well, again, just have put a hand there flipping you off because there's literally, you can't understand what's going on there. There were two networks. There was a /24, and they carved it up to a /25. And look at that. Why don't you just say, I'm not even going to bother telling you? Why don't you just put like one of those like red, like don't park here signs or something, and then just put like this behind it and just say, I'm not even going to tell you it. Because doesn't that kind of look like you don't care? Anyways, there's nothing wrong with this. Technically, this is correct. But there's like I think there's 1, 2, 3 words that aren't broken up. Oh, usable as well, but not there. This is terrible. But I use that as an example to show that this is not how you show people stuff. You should take pride in your work. It can be 100% accurate, but I guarantee you, even as you guys have been sitting here, and even as I explained what it was, and even if I broke down what a /25 network is, it's between 0 and 127, with the first usable being the 192.168.5.1 and the last usable 192.168.5.126. I guarantee you none of you can read that. So there's still no information there. All right, so be above reproach. This one is another one of those soft engineering skills that I just think all engineers should have. And the idea is, as engineers, we deal in precision and truth. I'm not saying that in some esoteric way. I'm not like sitting in a lotus position and floating an inch off the ground telling you like some grand poobah, type thing. I'm just telling you, as an engineer, it's a search for truth, right? We set ones and zeros. We check them to make sure those values are as we expect. So I'm going to tell you, one of the things dealing in precision is trust but verify what you're told by others. I have been called out many times over the years, late at night, where somebody tells me a server's down. Server's been down for 4 hours. And I go to the server, and the server's got an uptime of 32 days. And I'm like, guys, I need something else. Yeah, John Jones, you're a network guy, and you can read that. This is terrible right here. This. But, so we're down here, and I've been on calls, and I'm like, wait a minute, guys, the server is up. What are you talking about? You called out the Linux team, and they're like, oh, sorry, the service is down. And you go, that's a pretty big difference. Okay, let me go see. And then you find out that the server filled up or something failed or whatever it is. The thing is, people were probably grinding around for 4 hours trying to fix the wrong thing because everybody that came in the call repeated the same wrong information. So I'm going to tell you right now, always trust but verify what you're told by people. First thing I do on a system, if I SSH over to one of my Rocky boxes, this one just rebooted, I do an uptime and I do a last. Those are the two things I always do. I want to see who was in it, and I want to see how long the server's been up. This server's been up 53 minutes. This is a prime candidate for some, shenanigans happening to my server if a server just rebooted. If the server's been up 30 days, that's probably not a service that failed. But if it just rebooted, all kinds of things can be wrong with that server because there's an aggregation of changes that have happened for the whole time that server has lived until the last reboot, right? So anyways, if I say something on a call or I write something in an email to state some truth, like I found that server, like if I was going to send this right now to the people and say, I found that the server's only been up 53 minutes, what are we doing? Or what would you like me to check? I will immediately send that right underneath it, right? So if I was making an email, it would look a little like this, right? I would say, I found the server up for 53 minutes, and the service, is running. And then right here, I would drop that thing, and I would probably use like the indent function of my thing. But then I would have that there, and then if anybody ever came back later, this is why I say be above reproach. If somebody came back later and said, Scott was lying to you guys, that server's been up 34 days, I'd go, well, the server that you told me to check, which I sent right there as Rocky19 and said on the call, has not been up that long. He's been up 53 minutes. And they go, oh, well, before you got here, we were all talking about server 18. And you go, well, I don't give a fuck about that. All right. No, I don't care about that. It's that's not what we were talking about. Anyways, so my point is you can be above reproach because you can validate everything you say, right? You don't have to swear. I don't swear when I'm working because there's no reason to, right? In fact, most people, if they ever hear me yell at work, it's because somebody really messed up, right? And most people know if I am ever agitated, it's because something actually happened that was wrong, right? But then you don't ever have to backtrack on what you've stated because your engineering currency is based on your knowledge and understanding of the systems you work in. If you are constantly doing things wrong, people are going to look at you different as an engineer. I mean, I hate to say it like that, except it's just the currency you have as an engineer is what you know and how accurate your answers are. And if you're always giving wrong answers, it's going to look really poorly on you. That's just a simple fact of that. Okay. Don't talk about your feelings. It feels slow. This doesn't feel like the normal system. It's a little sluggish. We can quantify that. We can figure out from that something else. But just the feeling of a thing is actually an anti-methodology in troubleshooting. Does everybody here remember that thing a couple years ago where the guy found out because his SSH sessions were a little slow that there was that cryptography problem, and somebody had been injecting that problem slowly over a couple years? You guys probably find it if you remember that. But the point is, the guy didn't just he did notice it was slow, but then he went and he actually did a bunch of tests and found that his connections using a certain crypto library were like half a second slower. And he goes, wait a minute, these connections are slower. And then he found out from that something was wrong with the thing. And then people started digging in, and then they found that somebody had been trying to backdoor the whole thing. Data to based observations. So learn how to interpret the data you're looking at. Understand the scope, the scale, understand the mean, median, and mode, as well as distinct outliers. Let me just, well, hold on. I don't have this one as the presenting, but if I were to pull up like Excalidraw, or my little drawing tool, hold on, what is that drawing tool? Epic Pen. You guys ever seen Epic Pen? This is such a good little program. One of my buddies uses this. I just think it's such a good tool. Hold on, let's see if I can pull it up. So this is Epic Pen. If you've never seen it, ignore that. And you can just use it to draw wherever you want on a system, right? So I can just draw right here on this page. So I'm going to get my little stylus out here. And, if you're looking at data, right, and you've got just some data points here, right, and this is what your data looks like. Then you got one up here. You just got some data. And maybe you have a line drawn through them even for data or whatever the thing is. But do you understand, like, the mean? Like linear regression might draw something through this, and you can use tools to do linear regression, but it might draw something through it like this, right? And then maybe we automatically ignore outliers as we look at things. And this really starts to dig into, like, the engineering side of things, which we're not necessarily worrying about right now. But what's the scope? What's the scale of our data? Let me show you guys one. This will be a good example real quick on... If I go back to this was a drawing from earlier. Where was this? Here. When you look at, we can close the eye there and it'll make it dark. But we go right here real quick. And if you look at this over the last 90 days, this looks like a really slow uptick in band IPs into my system, right? But what if I did this? What if I went in here and I looked at all the band IPs? But then I do this sometimes to show you guys. Let's come down here. And instead of starting at 0 at the bottom of my axis, instead of starting at 0 and going to 55, what if I started this at like 53? Right? So I do that. And, oh wait, what was the top of that? Let's go there. All right. And then, but then I say, well, that's too much. I want to change that drawing. Let's go we want to change the top side. Let's change the top side here down to like, he'll go to like 53, 5. And I was using this one day to show that the way that we present data, you can start to almost be like an alarmist about data by being like, look at this great increase we've had over the last 90 days, and look at, we're about to run out. Clearly, looking at this, we're about to run out of whatever we're using as a resource within the next month, right? That's been 90 days. And if we continue out, we're going to cross right about here. And now I'm an alarmist. But you guys that saw the original data, you're like, what the hell is this guy talking about? We're basically at a static line across if we look at it like this. And we're never going to run out of those things at all, whatever they are, because they're just banned IPs in the system. So it's like, how honest honest are you about the data and the scope of the data and what we're actually dealing with, right? You can make up all kinds of stuff with data interpretation, guys. You guys just watch me change something from flat across to up over 90 days just by playing with some numbers on my scale, right? And looking at what the scale of the data were. So you can do that kind of stuff. And then I'm a big fan of avoiding all anti-methodologies for troubleshooting. Blind Man just completely keeps changing things at randoms until a problem disappears and then guesses at what actually fixes it. But that's not really good, because what if it's maybe it's a couple things that caused it to fix. Or maybe it's, just changing things at random until a problem disappears is probably one of the worst engineering things you can do. Right? It's bad adminning too, so it's bad. Spotlighting, only using tools you're familiar with. You gotta be good with the tools you're good with, right? I tell you guys all the time, if you get called out in the middle of the night, you don't want to be learning how to use your tool then. You want to already know how to use it. But you want to be open to use other tools if something else comes up. And if you say, well, Scott, I don't know where to get performance skills, right? I don't know that stuff. There's a really good, this guy, Brendan Gregg, Linux Perf right here. This guy's probably one of the best sites on the web for Linux performance stuff, performance tuning, and looking at your systems, right? Tremendous amount of really good stuff here around how a system, what tools am I going to use to see if my device drivers are working? Well, dmessage will show you if they loaded right. ETH tool will show you if they're connected to the network. And then IP and IWconfig and LLDP tool can tell you if ports are connecting to systems on the other side, right? Do I have an LLDP tool on my Linux box? I doubt I do. Nah, I don't have it. I've never seen that tool before. I know what LLDP is in the networking space, but here's where it comes from, LDD pad. And then we might be able to play with that a little bit. That might be fun. You guys are going to send me down a rabbit hole. So I don't need LLDP tool, I need LLD pad. LLD pad, yep. That should give me the, yep, I'll install it. And then let's go see, I'm curious what this is going to do. Just going to try to see what it can connect to. Query and configure. Interesting. So we can play with different interfaces if we want. We only have one interface we care about here. Right, and then we can go play with the system. Anyways, the point is, I'm going to go get too far afield if I go mess with that stuff. But be ready to go play with a new tool and figure out how it can help you, right? And then another one, man, I tell my junior engineers this all the time when I have different junior engineers I'm working with. Do not get on a call and blame networking. Oh, this looks like networking. That's like, honestly, one of the worst things you can do, guys. Because, one, networking already knows it's their fault and they feel very bad about it. And two, they're so tired of hearing it from people that once you do that, they're probably not going to listen to you anymore anyways. So, okay. No, but the point is, don't get on the call and start blaming right away. Start gathering your information, figuring out what you can check and what you can't. Maybe for me, I start grabbing notes right away on all the things that are aberrant. In the Linux course, we actually go over, in the Linux sysadmin course, I go over all the things I pull out of systems when I'm checking them. And then we can eventually say, as we test things and check what's right and what's not right, we can say, well, hey, all this stuff looks good on this server. but I can't get this connection over to this other machine. Has something changed in the network? The servers are both up, everything looks like it's running, nothing's rebooted, but there is some, something in between. And I've had this quite a lot in my career where they're like, oh, well, we were making firewall changes for, and it was put out and everybody was supposed to test everything. And it's like, well, that's like saying, hey, go check all your servers for everything. Well, I'd look over my servers and be like, well, my servers are working. But they're like, their point is, well, we did the best we can. Look, sometimes there's no blame to go around. It's just we need to realize we need to fix this. So then we tell them, hey, well, we need to punch this hole in this. Why don't we just fix this on a Saturday night, get it back working like it was, and then we'll do the emergency change on Monday morning. And that's typically pretty acceptable because the goal is to get the system back working, right? At least at the incident level. From an engineering level, we do want to figure out what was broken, especially from a change management team perspective, because what used to happen with us was before, so it was a non-restrictive environment. Everything could talk to everything. And they were dropping firewalls in, and what they were doing to punch holes in the firewall was taking any request that had ever been put in before, right? And nobody had ever had to put anything. Why would I have to put in that port 8443 to be able to talk to the Kubernetes API? Why would I have ever had to put that in if everything was open? I would have never put in a request for that. 8443 would have just been, or 6443, whatever it is. I think it's 6443 typically. That API would have already been open, so I would have never put in a firewall request. Therefore, nobody would have ever found it. When they lock down the firewall for PCI compliance or some other reason, then what's going to happen is nobody's ever going to go look back and see my request because I never made one. And then there's that. Yeah. Somebody was blaming the network guy today. Yeah. Yeah. And you're the network guy, right? So you're used, man, I tell guys, just don't get on and blame the network person. They already know that they're going to get blamed, right? Like if the network team is on, I don't think I've ever been on a call ever that they were like, get the network team on, where the first thing that guy didn't hear was it was your fault. Like, I don't think I've ever been on a call in my career. Like, and I've been the network guy for a long time. I was the network engineer, right? I did that when I first got out of the Army. I did that all the way till I went to GoDaddy and ran their NOC, all their network operations. You always hear it's your fucking fault. So don't be that guy if you're the Linux engineer, because then none of those guys will like to work with you. And I try to keep my team working with people well. So, all right. I always show you guys the use methodology for every resource check: utilization, saturation, and errors. Utilization is how busy the resource is between 0 and 100% utilization. Saturation is if you're at 100%, then the queues and the lines start to form. And then errors are reports and logs. They should be easy to spot because timeouts are being hit because things are waiting in line too long. That right there against the big four are compute, memory, disk, and then network, right? And I have that. If anybody wants this other presentation is here. This looks like this right here. This is the observability tools for the big four against utilization, saturation, and errors of a system, right? So CPU, memory, disk, and network. And a lot of this you can tie back to that same Brendan Gregg site that I was just showing you guys, right? All right. Let me get this out of the way. Office and online etiquette. I need to update this. This was actually one of the new ones. But this has come up a few times in our Discord recently where, like, I don't know, we're not in the office anymore, so we're sitting in, Discord and hanging out and stuff. But if you were in an office building and, people were coming in for a meeting and you were still sitting in there from the last meeting, you wouldn't still have your feet up on the desk and, like, still presenting until 5 minutes into the next meeting. That's definitely not the way. In fact, a lot of organizations institute always stop meetings 5 minutes before the end so people can get out of there. You wouldn't just stay in there and keep your feet up and stuff. And it's the same thing online. In a Slack or a Teams or any of those, you wouldn't just hang out in there and talk about whatever else as the meeting was kind of called to order, right? Does that make sense? So we've run into that in our Discord. There's a lot of etiquette like that, and I would tell you in the office there's a lot of etiquette too. There's, don't be one of the big ones is don't cook things in the microwave that's gross, right? Like people hate that, and that's just common etiquette. There's in fact some companies will have a sign up that says no fish and no popcorn. Now, fish just has a strong smell when you cook it again in a microwave anyways. And popcorn is perfectly fine until what? Until it's not, right? When somebody burns popcorn in a microwave and you're smelling it for the next 3 days, most people that sit by that microwave are not super happy. In fact, like nowadays, if I was being forced to go in the office, which I'm not, and somebody did that, I would literally just leave and go home. And I'd be like, all right, well, those are my work from home days now because I'm not sitting near that shit, right? If that bugs you, I mean, it doesn't really bug me, burnt popcorn. I just don't like it. But anyways, my point is there's a bunch of office and online etiquette that I need to add in here that, you would think it's just like, God, you'd think it's just common sense, but it's not. Some people, like, literally lived in their parents' basement and then they had to go in the office one day and, like, you have to teach them, like, not to eat other people's food and stuff, right? Like, it's weird. I had a boss, so we used to go to this place out here called Japan Express. Really good, like, teriyaki chicken. And we'd come back, and my boss would always only eat half of it, and he'd go put the rest of it in the fridge. And we're talking, like, guys, we at AAA, we had, like, an open floor seating plant with probably, like, 500 people in that building. And he would come back the next day and somebody would have eaten all the chicken off the top but then put it back in there. And I'm like, oh my God, dude, just throw it away at that point. He would throw it away, don't get me wrong, he wasn't going to eat it. But the funny thing was they would eat his chicken off the top of his teriyaki chicken and leave the rice and the rest of the bowl. Like, dude, just throw it away, man. Like, just throw it away at that point. But they would, I don't know, it's like as if somebody thought it was polite to put the rest of it back as like the evidence that like you're not losing your mind or something. I'd just be like, man, just take it all. Just I would just forget about it. I don't know. And I used to joke around because I'm like, why do you even throw it in there, dude? Like, do you want me to buy your lunch? Like, is it that much of a burden to you? I used to give him such a hard time. That same boss though was actually funny. We'd go over every morning. Me and my brother would walk over. We had a cafeteria, so they would make you eggs and biscuits and gravy and stuff. And I would put so much Tabasco on it that he would complain every morning. And I told him, I was like, it's not about the Tabasco. It's not about Tabasco for the enjoyment of it. It's to make you feel it. Oh, my poor boss. But anyways, that is an office etiquette thing that you shouldn't do. And then I had this other one too. I should show you guys this. I had this thing that I would always show him. Once every few months I would send him this email where the guy is, let me see if I can just find it real quick. I'll find it for you guys. This is also bad. This is all bad etiquette. Don't do this to your bosses. Hold on, I have to fight this boss real quick. I would send this to him every few months. You guys ever seen this? From the Side 9 Happiness? Damn it, William, stop playing video games at work. Give me a sec. I have to fight this boss. And then he hits his boss. He goes back to playing his video game. I would send this to him in text. Don't do this to your bosses. They'll probably take it as a threat. But yeah, I used to send this to my boss every now and then just to remind him. Damn it, William, stop playing video games at work. Hold on, I just have to fight this boss. Side 9 Happiness is pretty good in general, but this is one of their best. He's just fighting the boss. Oh my gosh, this is one of my favorites. It's just look up. Hold on, I have to fight this boss real quick. Oh my gosh, yeah. Just don't get yourself fired for it. But anyways, that's all poor etiquette. Maybe I'll do some poor etiquette examples of things that I've done. There's some bad stuff that you don't want to do in an office, like, and also in Discord, right? There's proper ways to jump in a channel and not just start presenting and being real loud when other people are doing stuff. There's all kinds of like just good etiquette that I don't think people are taught at home or something. So I don't know. All right, questions, hit me up, find me on Twitch. Here's what we're gonna do. We don't have enough people on Twitch to raid anybody, but you guys are welcome to hang out or go find somebody. I always advise people get down in the Discord. Discord's free. A lot of the stuff we were talking about today is in the Discord, so you guys can get it. And if you take everything out of there and run away like a cartoon villain with a little, all the stuff in a sack, I don't care, right? Like, I would prefer if people stayed, but if you just want to hang out and go, that's fine for me as well. So, I appreciate you guys all coming by. Let me just go to my little end of stream thing here. Normally I'm on camera, by the way, guys. The last couple of days I've just been not doing camera, so we'll get back going on there. Does Epic Pen work on a Mac? I'm not sure, Shunya. I'm not 100% sure. I've never played with it. over on Mac, but it might. It's a pretty good little tool. It's been in maintenance for a while, so should have some stuff. So, all right, I will see some of you guys later on this week, and I will be recording Unit 10 of our security engineering course probably on Thursday night. Oh, excuse me. And that's probably going to be a 2-hour recording, and it's just going to be a brain dump of everything that we did. So, all right.